I do not want to try again. I feel like we got an answer, and that should be suffice for now.
He said we got an answer. I feel that. I feel that. All right, let me see what else we got here.
You want to go back to? I really want to understand, like, be really good at intervals, because like I feel like intervals are usually like a intuition thing. Like, you know, do it enough to understand like what methods to use or like what strategy to use.
so you want to do that
And
like overlapping interval problem?
something we haven't done before. So let's see.
We didn't solve that one. We just attempted it. So I mean, technically, it's not solved. Can we warm up with that penalty shop question? And like, can I like lead? And if I get stuck, can you like kind of like lead me in the right direction just to make sure like the logic is right?
Yeah, sure.
All right, cool. It should only take like not that long because I thought about it a lot when I was like I went for my run and it kind of made more sense. And yeah, hopefully, let me send it to you. And then you could if you have the interval problem pulled up, we could do that too. Dude, you should post your Leetcode rewind on LinkedIn. Like only one time to really post it in the year.
What's the rewind? What is it?
Like you don't see like when you go to the homepage of Leetcode, it says Leetcode rewind. It tells you like your stats for the year and stuff.
Mm,
I'll show you after this. Uh,
okay.
okay. So what I got from this question is okay. So you want to figure out the best time to close the shop. Let me start the timer. 45 minutes. We should not spend. It should be done in 15 though. So you want to know the best time to close the shop, and you can close anywhere between 0 to n-1, where n is the length of the customer's array or string. Or n, well, 0 to n actually. And the maximum penalty would just be closing the shop at the 0th hour, which is like before any customers come in. And your penalty would be the number of Ys because you closed when all the Ys came in. Next, so we're gonna have like a variable. I'm gonna call that like max penalty. So maybe I make some comments. So max penalty is the number of Ys uh at hour 0. Okay. And then next, I think we want to have a res, right? Because like that would be the time that we return. Will just
Yeah.
equal the max penalty. We return this value at the end. Okay, I think we iterate through customers. Okay, so this is where it gets confusing. If wait, no. Res should not be the max penalty. This should be our penalty. This should just be penalty, right? And then res would be 0. That's like the time that we start at, right?
Yeah.
Okay, it makes more sense. So this is we don't return this at the end. uh, res, which will hold our best time to close. Okay. Iterate through customers. Okay, so let's say we have like the first example here, y, and y. If we see a y, so before we start it, we would assume that we close at hour 0. So if we see a y, which is stands for, this is where it gets confusing because like, what does y stand for? That means that customer came in at hour 0, right?
Yes and no.
You said yes, no,
Yes and no. Yeah.
yes and no. What does that mean?
So Y is like our map, I guess, in the beginning.
Yeah. So
So
when we see
like
y, the first
we
one, what
have
does that
we
mean?
have a set schedule. So like first we have a set schedule, and then we check if we follow the set schedule, what would be our hours?
All right, so if we look at the first y in customers in example 1, that means there's a customer comes in at hour 0, right?
Yeah,
Okay.
or hour one. You could say hour one to
So
make it much
0
more.
actually represents, so the first, so customers, we really have to look at it as one index, right?
No, zero for next.
But you just said that the first y represents hour 1, so that means that we should be looking at the first y as 1, no?
That's not what I said.
Wait, what'd you say with that one thing then?
Um, so the first customer is at index 0,
Correct.
and then the s- the overall map or schedule is the initial uh, graphing or mapping,
When you say schedule or map, what do you mean by that?
like what they give us.
So the customer's array? I mean, string?
Yeah, yeah.
Okay, so if we see a y, what does that tell us? That means that customer came in at hour 0, right?
You could say at hour one because there's no such thing as hour zero. You can't come in at hour zero.
So wouldn't that mean that we read this in like one index? Because so the second one would be like the customer coming in at hour 2 then?
Yeah, that could be a good way to think about it. Yeah. So
Okay. Okay. So we iterate through, and if we look at the first one, is a customer coming in at hour 1, then that means that if we close, no. That means I guess they come in at hour 0, but if we close the shop at hour 1, that means that our penalty should go down because that means that they that we can serve them, right? So we lose a penalty.
yeah.
Okay. I'm gonna say using shit. I'm not typing correctly. Enumerate if I don't know, char is y, subtract 1 from penalty because we can serve them if we close at our I plus 1. That makes sense?
Mm, mm-hmm.
Okay. So we just do the inverse. So if char is n, all right. So if the first one was n, what would that mean? It means wait, don't tell me, don't tell me. If we see an n, then we our penalty has to go up then.
Mm-hmm.
Yeah, but doesn't that mean that the penalty will go higher than 3?
Mm-hmm.
That's kind of weird, even though it's impossible. Okay, so
Wait,
if chart, because like how, like you can't possibly get an hour a penalty of 3. Wait, can you? I mean, a penalty of 4.
for the first example,
Yeah, for example, you can't get a 4. You can't get a penalty of 4. Greedy.
well, you won't, but you can. So, like, if you
How?
have 4 slots, the maximum penalties you have, or 4 days, the maximum penalties you have is 4. And since we have 4 in the first example, our maximum penalty could be 4.
How? Because they just the explanation goes through closing at all the possible hours, and none of them are at 4.
Yeah, for this example, you won't, but you can if
Oh,
the numbers are different. I mean, if the letters are different.
so if char is n, then we add no, yeah, we add 1 to penalty because if we closed at I plus 1, we would be open. We would be open while no one was there. General. So, okay. If this doesn't work, I'm pretty sure this is good though. All right. So here we have if we see a y, if we see an n, I think I got this. I think I got this. And then, oh yeah. So if and then if if penalty is less than max penalty, that means we found a better answer. Res equals res equals I plus 1 and max. I'm just gonna max p. Max p equals p. That's it, right? And then return res.
Mm-hmm.
All right, I'm going for it. Okay. I'm just gonna call it max p. Max p equals customers dot count y. I don't think this is supposed to be here. P equals. Wait, hold up. Max p and res equals 0 because that's where we're starting from. For I char and enumerate customers, customers. Yeah, yeah. Okay, so now we just do if char equals y, p plus equals 1. I could just do else P minus equals 1. No, that's wrong. Penalty should go up if we see it in the end. A penalty goes down because it will be open. Okay. If P is less than max P, then res equals I plus 1 and max P equals P. Yeah, I'm cooking right now. I think this makes sense. I don't know if I consider this cooking because I literally knew the answer, kind of, but I like reasoned it out. Let's go, baby. Let's go. Yippee. Um. Wow.
Cool.
I still can't believe you got that so easily. You know this question is a contest question. Like they asked this during the Leetcode weekly contest, and you got it. Like if you were in that contest, you would have cooked because you got that shit like 7 minutes.
Can I get it in an interview, please?
Like this is literally probably like an interview level question. I have this extension that tells you the rating of a problem. They only do the contest rating, and this one they gave this one like around 1500,
Of
which
what?
is like basically like they just give you how like there's always just says medium, but you don't know how hard a medium is. It kind of gives it like a finite number, and this gives it around 1500. And like I
What's
guess
the
two.
scale though?
What's the skill?
What's
I
the
guess like
scale?
scale.
Like,
Um,
what is that number? I don't understand.
like a pretty hard medium, I'd say.
Okay. Bro, I was thinking, can we go back to binary trees? Because I feel like I did grasp it once we've left, but now I'm looking at other binary tree problems. And I'm like, did I really grasp it?
Wait,
Oh,
so
goodness.
binary tree over intervals?
Yeah, yeah.
Okay,
And
send
I
the
try to look
problem.
at so
You see,
like
to try to look the what?
I don't know. I try to look at for like binary tree problems, and I mean interval problems. And there's not a subject for
I
it,
think you just
so
type
I
in
feel like
interval because they usually have like the word interval in them.
and I didn't get anything. I don't know why. This is like maybe
Wait, I
my
did.
filters.
I have
Oh,
insert
you did?
interval, remove interval. Oh, that's premium. Interval concatenation. Did you just type it in the like the problem like question? Like where you search for a problem, just type in interval. Oh, unique
In the
binary trees.
I did the filter.
Oh, I didn't know. Don't do filter. Just type in the word interval.
Oh,
Dude, we actually got that question right. I'm pretty happy. Oh yeah, welcome back to the stream, brother. I'm glad. I appreciate you pulling up. I had to lock in real quick. I didn't want to talk while we were inside the question. Oh, brother. Unique binary trees. Okay. Search trees.
I already don't understand this problem. Like, like I understand it, like what they want us to do, but I have no idea of like how I should tackle it. At least yet.
Okay, we need to generate an array of all the numbers from 1 to n. So like let's say for example, like since n equals 3, that's not an equal sign. We should have like 1, 2, 3. Now, since binary search trees are like everything on the left is less than, then the right is greater than. I think we should like pick a root number. So, for example, let's pick 1 as the root.
Do we exhaust all possibilities? Is this like a
Yeah, it's kind of like
that was
backtracking, I think.
yeah? And
Oh
then you
no,
only
it says dynamic programming. Oh brother.
backtracking is dynamic program, except the brute force DP. That makes sense. Remember how you
Oh,
can from backtracking to memorization to DP?
yeah, that's in one form of DP. Because like, what about tabulation?
Yeah, tabulation is like the final boss.
Yeah, for real. Like, yo. All right. I don't think we're going for no DP approach though. All right, so let's say we had an array like 1, 2, 3, and first we just pick a number that'll be the root. So in this case, 1. Let's say like root, and we'll have a for loop that iterates through. We'll choose 1 is the root. So root equals 1, and then we have like a subsections of the array. So since it's sorted, we're gonna know everything to the left of 1 will be in the left subtree, and everything to the right of 1 will be in the right subtree, right?
Mhm.
So that means that left will equal the empty array because there's nothing to the left of it, and right will equal 2, 3.
I think there's an easier way to do this. You're slicing. This is a really great way to start. I, once you said this, I like had like so many ideas. But
Oh yeah, we don't have to slice, but it's just for like explanation reasons.
okay, continue.
Uh, yeah. So that means that the left subtree will have nothing, and then I think we're gonna have like some type of function called like DFS, and it's gonna go through until we use up all the numbers. I don't know if we're
Yeah,
gonna call it count or something, or wait, no, no,
just
no,
yeah.
not the function name, but like to know like the base case.
No, it's
I
still
think when
DFS
mm, yeah, it's gonna
because
be a DFS, but until I guess it goes until all the numbers are empty, all the lefts and rights are empty.
yeah, and then backtrack. And then if we hit a valid subtree using all numbers, then we increment our arrays to +1.
I think the way we're doing this, all every time we use up all the numbers, there'll always be a valid subtree. Like just based on like how it's like sorted, you know.
Yeah, yeah, if the tree is
So from this point on, we still have the root of 1, and then I guess we have two functions that'll get the left and right subtree. So left will be 0, and then now we have to do the right, and I guess we just pick the first number as the root. So that'll be 2. Everything to the left of 2 is nothing. Everything to the right of 2 is 3. So that means 2 has no left, and a right of whatever DFS of 3 is, but 3 only has one value, so it should just return itself. And that'll be the first one, then it backtracks back up. That makes sense, right? Like, I didn't draw it out, but I'm thinking you're following, right?
what's the last part? What's the last part?
So,
Line
like,
7?
line 7. Okay, so, we pick the first number is the root, and we'll say, hey, this is the root of the right subtree. And then everything to the left of 2 will be the left subtree. So as you see in the first example, oh, no, as you see in the first example, second tree, the second value is a 2 and it has no left, just like how 2 has nothing to the left. So left of 2 will be like an empty array.
Yeah, I got it.
And and then the right of 2 will be 3, just like it looks there. And we would return, I don't know, 1 plus whatever our global variable is.
How would you get this value without slicing?
That's why I sliced, but you said there you had some ideas on not slicing, so like I'm down to hear them. Oh, we got
What if we
pointers.
yes. Yes, that's one solution. What if we just did +1 and then try that possibly and then return if it doesn't work?
Plus 1.
So
Like,
root
show
out
me.
that root, right? And then +1. So like let's say we had interval 1, like exactly how we do like backtracking, but we
Okay.
just do plus 1 from where we are right now. So our root dot left is +1, so that would be 2. And now root dot right is always it's also
Wait,
plus.
what? But our left should have nothing in it though.
Yeah, we're gonna try it. We're gonna see that it doesn't work.
Well,
Or
how would you know it doesn't work?
we could have an if condition that says if +1 is not equal to x less than, and then same thing for the right. If +1 is not equal to greater than the current, then don't do it. You go
Wait, I
another
don't think I
+1.
understand. So like we're here with 1, 2, 3. So are we making the array, right? And where do we how do we start off? Like from here.
root.
So we're gonna call root, and instead of equaling 1, it's gonna equal 0 because the index, or
No,
what?
no,
No. Okay. So how? Well, yeah, I don't get it.
one, one. So uh, our function call is DFS and then the index. Right? The index is 0, so
Oh,
it's DFS 0. So
so it should be like tree of I is really gonna be the root. Whatever I for index, and tree is the array.
exactly.
Okay.
And then so we have as soon as we enter, well, we're gonna have our base case saying if we've exhausted all our possibilities, then
So if I
if
equals
the tree is full,
n plus 1 or n, yeah, if I equals n, right?
we need a proper base case.
If I
Because
equals n, because when we go up each time.
no, because then the root could be oh, this is like shouldn't like what is that? Is that permutations? Because permutation says that shit. All right, a little too complicated for me, but I think our current solution works. So I'll come back to it, but
Hmm.
'cause,
Wait,
like
is this permutations or is this sub? No, I think this is permutations because it's like it's just different orderings and orderings matter.
exactly. So
I don't
if
know
we
how
did
that
a
helps us though.
permutation of this, like if I can remember how to do the permutation correctly,
I remember how to do it, but yeah, I
and then
remember
we
how to
just
do it.
add an extra condition um for when we go down a level, you know?
Oh, okay. I kind of get what you're
So,
saying, but I don't know. Like the details are a bit fuzzy. But yeah, I kind of feel you.
so if like permutations, we need like a dictionary, right? Of some sort.
Uh, yeah, like a counter.
No?
Yeah, yeah, you need a counter. But no, we don't. We could use an array of true and false because everything is distinct. You only need a counter if all the values are if there's duplicates, so you don't reuse the same value twice. But you want? Can we just do the brute force if you're down, and then maybe like try to optimize it?
Sure, let's do it.
Okay, so let's write some comments. Uh, so I'm thinking we're gonna call it tree. Will I know you like writing English words, but like I'm just gonna put tree will equal. Come on, like everyone knows what that means. Like, come on, you don't have to write equal. Tree will equal like basically numbers 1 to n. Boom. Array. Bam. Uh, res uh, return value. Boom. DFS DFS function uh takes in, what does it take? Left, right,
Left.
right? No, 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 no. Something doesn't make sense with that. Because how do we
No,
pass
wait.
in the first array? Just an array, right?
Yeah.
And then, okay, this is where the fun part happens. If, I think if the length of array is 1, we just return that value, right? Because, like, let's say we're at the 2 and you looked everything to the right of 2, it'd just be you just want to return 3.
Wait,
That
what?
makes sense.
Wait, explain that again?
It's like if you're at 2 and you look to the right of 2, it would just be an array of 3, right? But there's nothing you could do there, so you just want to return just that value. So if it's of length 1, you know you don't have to go any deeper because it's only one value. So the only thing you should just return that value.
But why?
But if Why not?
How does this help us in our recursive recursion?
Like when we're at 2 and we pass in and we say DFS, we right equals DFS of and then 3 for the right, everything to the right of 2. You want it to return 3 because that's the node that's going to be on the right hand side. And if there's only one node left, that's our base case because that means we've taken out all the other nodes. But if there's more nodes, we have to go deeper. But if there's only one, we know this is the final. This is like the base case where
But
there's no more recursion.
wouldn't that be when we're doing our splitting where if it's empty, we're not gonna recurse down?
I think we may need 2 then because one we need to make sure that it returns the value if there's one, and if it's empty, yeah, and if it's empty, return 0. Unless you could figure out some way to do it both those in one way.
Isn't our slicing thing says that if like this is gonna recurse into an empty array, this array is gonna be empty. And then if this is empty, then that's where we recurse back.
So what do you do when there's one though?
Why do we need a condition for when it's one?
Oh, I guess you could just let it go all the way down, and then it'll go to the left of one, the right of one. Both of those will be empty. Yeah, I guess you could do that. Yeah, makes sense.
But my question is, my worry
Mhm.
is, I still don't know when we increment our res variable. Um, so is it when the array is empty or like when we can, um,
I think when the array is empty, because that means we've used up. Wait, no, because the array will be empty on the left hand side of one, but not the whole tree.
so it's probably after we call root left and root right, and then we would say, um, if they're both empty, then we would increase our res.
I'll be
Because
honest,
if the
I
array,
don't, I don't know. I don't know. I gotta
if the
think about this. Hmm. Wait, so wait, when is the? You want to just keep writing and maybe it'll come to us, like, because there's a lot of other stuff we gotta write too.
it's like 5 lines left. Okay.
I mean, unless you got the answer, like I don't
Yeah,
know the answer.
well, we could keep writing. We could keep writing. Yeah.
All right, so we do know the
If
base case is length. If the length of array is 0, what do we return? Like nothing, right? Just return, or do we have
yeah,
to return an empty array? I think we
yeah.
might have to turn an empty array. Yeah, 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 yeah. At least like 3, 2, 3, 4 around there. Assign root to left value. Oh yeah, the leftmost value. Yeah, my bad. Uh, left is everything to the left
Wait a sec.
of,
1 second. 1 second. 1 second. Isn't a BST
yeah,
a binary search tree? Is what's that algorithm that
everything
we
to
use?
the left is less than the parent. Everything to the right is greater than the parent.
Yeah. So aren't we using like middle, left, and right? So isn't the root assign root to the middle, right? The middle of whatever. So like,
No, 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 no. Wait, no, no. I see what you're saying, but you need
oh
to
yeah,
check if the
try.
root could be all of them. You have to iterate through all of them. I think
Yeah.
we might need an I or something. How do we? Yeah, no, we do have it. Do we have it? Because we have to start off at root of 1, then root of 2, then root of 3. I'm not sure
Okay.
how
All right. So
we
we're in the
do
right
that.
direction. All right. Yeah. So we could still do assign root because, like you said, we're slicing every time. So the index 0 is going to be different every time if we start here, right?
But that's going down like the recursion tree. What about when we get back up to the base? How do we go back and start at 2? Like what makes it do that?
Oh yeah, we
I
need
think
a
we need like a for loop, man. I think we need a
we need
for
a
loop.
yeah,
This
we
is
could do
kind
a
of just like backtracking, like the literal backtracking algorithm.
I'm thinking we could do a a global I or a for loop. I think
I think a for loop makes sense because that's like the basic formula.
yeah.
All right, yeah. So I think we do like. Doesn't that mean we need a start? We need a start so we can go through I+1.
Mhm.
Uh, so it takes an array
Let's
and a
let's do that for a second.
start.
Let's think about this for a second.
Okay. It's just like subsets or
Because
permutations. Like
because
you got an array start.
how do we appropriately what would be our start if we recurse to left?
Start if we went left from 1. Well, it wouldn't even get that far because it would return an empty array.
Yeah, but let's all right, all right. What would be our recursion if we did a right? Like we would have 2 and 3 in there, but our start needs to be what's our start? Start would then be 0 again, right? It would start
Yeah,
at 0. All right.
yeah.
Okay. All right.
So we don't do +1 in the DFS call. We call it the same because we're slicing it, and then only after it iterates through, then it goes up. So I don't think we need a start. Yeah, I don't think so.
No, we need a start for the initial one. Remember?
The initial one, but it starts at 0 though. Oh, yeah, yeah. For the initial one, yeah, yeah. Everything to the left of root, and then yeah, right is everything to the right. Uh, I think make sure it's in a. Wait. Actually, do we even need to put it in an array? I feel like this is like we only have to count them. Do we really have to like we're not actually storing anything anywhere?
It didn't even
Hmm.
give us a tree node class, if you noticed. So maybe
Oh
we can
nah, yeah, no. We're just like going through the numbers. This is like I don't know, like simulating it. It's not really a real traversal. Just like when we have a graph and they give us those numbers, but there's no real graph.
yeah.
I think we're good.
No. I mean, we still haven't decided where oh, but let's get there. Um so do we need to assign a value? No, let's not assign a value. We could just go left and then right, not include
Yeah,
in our current route
yeah.
first.
I think we have to call it DFS on both of these though,
Yeah, of course.
not including. I don't think you even have to put that because if like doesn't this like implicitly like mean that? Because if it's everything to the left, then it
This
wouldn't
is
include
for us.
it. Oh, okay.
Just for memory's sake. So make root equal to running is 0.
Shit. All right, there we go. Yeah. And we're calling DFS on both of these, right? So shouldn't that
Make
return the left and
make
right subtree?
make new roots equal to array of 0. Do we need this?
I don't think so. It goes before we decide to make our for loop. Do we even need a fucking root? I don't know. All right, so
We
let's think
need
about this.
we need
What happened?
something that tells us that we have done 3 recursion. We have tried 3 different numbers. So
We know
let's
that
say
when they
that
both return
increase
an empty array.
increase our total value plus 1 here.
What
Every
the hell
time I
is
reach
total value? Oh, res?
because we need to know if we have done n different we have placed n different possibilities inside of our imaginary tree so that we know that we can increase our so that we can then um, increase our res value plus one because we need to know
So you're having a
if our
counter to count the number of nodes we've placed.
yes exactly.
But if left and right, no, I don't think so, man. I feel like if left and right are both empty, wouldn't that mean that we've used all the nodes? You don't have to have another variable for that.
So we're not keeping track if our lefts or right.
But we have them in the array. Like
Where?
we are, because we're storing in a variable, left and right. If they're both empty, then that would mean that we've used up all the letters or the numbers.
What do you mean?
Like if we go DFS left and it returns an empty array, and we go DFS right and it returns empty, wouldn't that mean we used up everything? There's no way to use like our slicing to know if we used up everything.
I mean, we could use two different slices here. Like we could create another uh, left and right and say if these two things are empty, then we increment. But
Oh
why
wait, no,
doesn't
no,
this?
no. Can't we just do no? We could do this. If left, if the so the left is going to be all the nodes on the left subtree, right?
Mhm.
The right's going to be all the nodes on the right subtree. So if we just do left plus right plus one for the root node, and if that equals n, then we return plus one because that means we used up everything. We don't need an extra counter.
Left plus right.
Plus one for the node that our root node, because remember we don't have the root node anymore. So left plus right. So in this case it would be 0 plus 2 because everything to the right of 1 has two nodes. So 2 plus 0 plus 1 is 3. N is 3. That means we used up all the nodes. Therefore, we've created a binary tree that works. Res plus equal 1.
When we would return this, the
At
left
the
and
end, after we DFS left and right, down here we just say like if the left plus right plus 1 equals n, then res plus equals 1.
so this has to return something.
We're storing left and right will hold the left and right subtrees. So in an array. So if we just do the length of that plus the length of right, then wait, do we even need to store left and
Bruh,
right? We
what
could
is wrong with this? What is wrong with this solution? Why are we
because there's
doing
like extra wait, because
what?
it's just extra work for what? If we literally have what we need here. Does this not make sense? Left
No,
would
it
be an
doesn't.
empty array. Right would be 2. So if left plus right plus 1 equals n, we've done it. We don't even need to have like
Why
extra
would this
variables.
return though?
Why would what?
Why would it return two? Nothing here says it's gonna return two.
So what is this? What
The array
is this
size
gonna
is
do?
gonna the array size is gonna the array size is gonna bring two inside of the function call of an array that equals of size two, and then we just do the iterate through it again.
I think it's because we haven't finished it because we haven't put our return statement. That depends on because I guess I was thinking ahead, but we're gonna have to have a return statement, and I would have returned whatever the nodes are in their left or right subtree. So what are you gonna put for the return then down here or whatever?
Why do we need a return statement?
Oh, so you're not gonna return anything?
So if the node equal to n, then we're gonna have two return statements right here.
If the node equals n, if the node equals n, but
If
how does that? I don't think that makes sense because what if like this
oh,
starts off at 3? Then that we would
like if if total equal to n, then we increase our res.
so this is gonna have to have another variable. We're gonna have array start and total.
Mhm.
Okay. I still think that there's some way to do it with these calls, but I don't know 100%. It seems kind of foggy. All right. So we have left, right. And what is left and right going to hold if we call DFS on them? And if, for example, left would be an empty array, right? So it'd just be like something like that.
Yeah. So if it's
What would
empty,
right be?
return 0.
Yeah. Oh, yeah, for 0 nodes. Yes. So if it returns an integer, that'd be perfect. So we want this to return 2. How do we do that? I don't know. I don't know. Okay, think about this. So if we have 2, 3, it's going to iterate through. We're going to make 2 the root node, and then everything to the left of 2. So 2's left will equal 0, right? Because everything to the left of 2 is nothing. So wait, maybe you should have this. Yeah, return 0. Yeah, I think not an empty array. I think it should return 0 because we don't actually have to need the path. Return 0, right? And we'll write equal. Everything to the right will just be the 3. So we call DFS. We have to call DFS on 3. And then what happens with 3? 3 will have a left of 0, a right of 0. And see, this is where we need to return something. Because if 3 gets a left and a right of 0, we need to go left plus right plus 1 for the node that it's at. And then that would return 1 back up to the 2 call that called it. And then 2's right will be, yeah, 2's right will be return up 1 plus the 1 node it was, wait, 2. Yeah, return up 1. That's perfect. Right? Doesn't that make sense?
I'm not following.
Okay, so do you get why we're returning like 0 here? If there's 0 nodes? Like empty array means there's nothing on that tree.
Yep.
Oh shit, we just hit the 45-minute mark. I'll quickly explain so then we can go on the break. So we're returning the number of nodes in the tree. So if we have 2, 3, so you get why left equals 0, right?
Yep.
So we call right, you get why we call DFS on 3.
Yep.
Okay. 3 is gonna get a left and a right of 0 and 0, right?
Yeah.
So that means that call is done. So we have to return something back up to the 2 that called it. So left plus right plus 1 for the node we're currently at. So it would return up 1 because that means there's one node on the right hand side of 2. So that means 2 will get a 0 for left, and this will equal a 1 for right. And that's exactly what's happening on 2. 2 has a 0 left and a 1 for right. And then since 2 just finished, 2 is going to return up to the 1, left plus right plus 1. So it would be 0 plus 1 for the current node we're at, plus another 1. So the 1 is going to get, so DFS of 1, when we're all the way at the top, will be left plus right plus 1. So 0 plus 1, and then plus the current node we're at, which would be 1. So that'd be equals 2. And if you look at 1, 1 has 2 rights, 2 nodes to the right, and that's perfect.
Okay.
And then with this information, when we're at the 1, at the top call, can't we just do the same thing? Because I didn't write it down here, but 1 would have had a left of 0. So 1 would have a left of 0 because it's empty, and its right will have 2. And then at the last call, we do left plus right plus 1. So 0 plus 2 plus 1 is 3. And that means that we found a valid path because it's 3. And then we just rest equals to 1 because we're storing the numbers, the number of nodes on the left and right subtree that follow the structural integrity of a BST. You know what I'm saying?
Yeah.
All right, so we do need a return statement somewhere. But we have been 45 minutes straight. I want to take the break, so we'll be back at. You gotta leave at 10 again.
Not today.
Okay, so we could take a real break. All right. I say like 8 minutes. We took 45 minutes straight. Take 8 minute break. 5 to 8 minutes, something like that. Maybe 6 minutes.
Okay.
This question is kind of tricky, but I feel like it's going well. Anyway, I'll be back. Are you ready to rumble?
Yes.
Alrighty, let's get back into it. Okay, so we're not returning zeros, we're returning the number of nodes along that tree, which would just be left plus right plus one. Okay. Mm.
So if we go with your solution, we can delete mine temporarily.
You
Forever.
just he said temporarily forever. It's crazy. I think we still need to start though. I don't know. I don't know if mine works though.
It makes sense.
But
So
like, I
what you
feel like there's an issue with this whole like left right inside the for loop because it just keep getting overwritten. There's like a problem there. Because where are we gonna return left plus right plus zero plus one?
here?
But like, if this iterates like like n times. Won't this the left and right will just keep getting overwritten?
Oh, so we could do it here.
I think so. I think so. I think we just do like yeah. Oh shit! What just happened? Oh, return left plus right plus one. Because like if we're at three, left, right would be 0 plus one, so you return it up to two. Yeah, that makes sense. Wait, where do we do the whole like plus one to our res variable?
So we definitely need to return something outside the return statement, or else this would return null at some point.
Oh,
So I'm thinking.
wait. I know what to do.
Mhm.
Wait, fuck. No, I was gonna say maybe have like a since this is a for loop that's gonna do all the counting for us. What if we had like count up here, and then we had like if left plus right plus one, one equals the count, and then we just return count at the end, and we don't need the res outside. It could be inside right here. I think that's like better for our structure. What do you think?
I don't understand. Say it again.
Like, so we have a count at the top, right? And since we're calling DFS within a for loop, it'll keep changing. So every time we call it on the left and right subtrees, if we get left plus right plus one, if it equals three, we just say count plus equals one. And then it'll just go on to the next one and the next one. And then how many ever this count equals by the end of this for loop, we could just return down here.
So what you're saying is increments f left plus right plus one equals n
Yeah. Pretty much just count plus equal one. And then we just return
increments.
count down here. And then now we don't have to have any like outside variables. It's actually like if this works. So whatever DFS returns will return the number of trees we can make. So we don't even have to. It's like the most pure solution ever. We don't even need the res no more. Just return DFS.
And return.
No, we don't return anything there. Just add count. Return down here. Because count's going to keep going until this for loop goes through. It's just, we're only doing that because
Return.
these left and rights will keep getting overridden.
We need to return the right and left to know like what it's equal to at some point.
Oh. Wait, this doesn't do that for us?
What?
Wait, so what happens in the first iteration? So left is going to equal 0, right? The right's going to go through and pass in the 2 and the 3. The length of the array is not 0, so we don't return 0. We iterate through the array. And left of 2 will be 0. Oh, yeah, I guess we need to return up somewhere. Yeah. Damn, does this work? That made it slightly more confusing. I think these have to be on two different lines. Not really. Maybe it doesn't have to, but I think it'd like be more like clear. Because don't we, what do we return here? We have to return the left plus right.
Are we ready to go back to my solution? Because I can't think of anything.
No, plus equal 1. And then I think this may work because when it's at the 3, 3 will go down and have left and right will both be 0. And it would do plus 1. It would return it up to the 2. So 2 is dot right will be 1. Its dot left will be 0. And then is will return up left, which is 0, plus right, which is 1, plus 1 for the current node we're at. So it'll return up 2 to the 1. And then when 1 comes out, I think this makes sense. But like we computed it twice. I think we just do this. And then there we go. If total plus 1 equals n increment. Yes, 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 yes. I think we're good.
Let's do a trace.
All right, so we start off at 0. We start at 1, 2, 3. Everything to the left of 1 will be 0. So this will equal 0 left. Right will go down, and it's going to have 2 and 3. It's going to call DFS on the left of 2, which would be 0. Actually, maybe let me do it like down here. So from the 1, left will be 0, and right will be like, I don't really know how to write this cleanly, but I'm just gonna do DFS of 1, 2, or no, 2, 3. Now we have to do DFS of 2, 3. So for 2, we get DFS of 2, 3. Everything to the left of 2 will be 0, so that will return up 0. Everything to the
What's our
right,
count? What's our count?
0.
Okay.
Everything to the left of 2 will be 0, so it returns up its left will be 0. Everything to the right of 2 will be 3, so we have to call DFS on 3. We call DFS on 3. Everything to the left of 3 will return up a 0. Everything to the right of 3 return up a 0. So now we hit this line here, and then it returns total plus 1. Total will be left plus right plus 1, so 0 plus 0 plus 1 is 1. We return that up to the 2. So now 2 finally has been resolved. So 2 will get a left of 0 and a right of 1. Now we return back up to the 2's parent, which is 1. So we do the total, which is left plus right. So 1 plus 1, so 2.
Mm-hmm.
Back up to the 1. And then 1 finally got resolved. So 1's left is 0 and 1's right is 2. So we do 2 plus 1 is 3, which equals n. So count goes up to 1. And then it says return total plus 1. So we'll just return 3. Let's stop the for loop though, because we need to go again.
Yeah, we are gonna go again.
Yeah, and then we'll just keep doing that. I think that makes sense, because count should go up to 1. As long as this return statement doesn't like break the for loop, we're fine.
This, we didn't use this. I think.
It's because I didn't trace it fully. Because if I traced it fully, I'd have to build all the trees. But yeah, if we went again, instead of starting, it would backtrack back up. Yeah, it would backtrack back up, and then it would have to go 1, 3 instead of 1, 2. So how would that work? So right now we've built the second tree though, 1, 2, 3, all going to the right. So what's the second tree it would build? It would have everything to the left of 1 would be 0. Everything to the right of 1 would be everything to the right of 1 would be 2, 3. How do we get it to grab the 3 first this time? Oh wait.
Wait, what?
Last time we did the 2, everything to the left of 2 and everything to the right of 3. Since we're iterating through, we should start off with the 3 this time. So everything to the left of 3 will be 2, and everything to the right of 3 will be 0. So that would make the first tree there. See that tree? The first one? That would be that one. And since we've iterated through the entire list, we'd backtrack back up, and then we'd start off with the 2 and do that again. And then lastly, the 3.
Mm-hmm.
How do we make... Are we sure to... will this iterate through the list, though? Depends how we iterate this.
Why not?
I think so. So it won't actually return 1. Count, by the time count goes to the 2 for the top DFS, the top for loop, it should return 2 because there's 2 trees that you can make starting with 1. And then it'll go on to the 2. Yeah, I think that's good. Let's try it. Wait, what do you think?
Yeah.
Okay, so I don't know, the for loop I'm a little fuzzy on, but I think it may be good. So we're gonna say tree equals. I'm pretty sure you could do this like range.
Oh yeah, you made a valid point there. For that second iteration of full map of 1, 2, 3, all in the right path. It's like if we're traversing or recursing down 1, we grab the 3 and the 2. Um, we grab the 3 and the 2. We put it in the right pointer in the right. And then we would traverse down again, just grabbing the 2 alone. that works fine. Then we have to traverse back up to the one in the for loop and grab the two first. So it's gonna
But that's why we have this for loop, because the next when we call DFS on the 2 3, it's gonna start off with 2 first, and then since the for loop will iterate through and have to call it on the 3, and that'll get us another call. So when it goes up to the 1, the count should be at 2 because there's 2 valid trees starting at 1.
okay. Let's do.
All right, so I think we don't really need to start. I think we just go DFS and we have. I'm just gonna. I can't call this tree array or something. Array. Oh yeah, and just start will only be for the first one. If length of array is, I'm just say if not length of array, return 0. Count equals 1. Yeah. Left equals DFS of array. Just I. Wait, wait. Why you go n plus 1?
Why not?
What? That cannot be a valid answer. I'm not saying it's wrong. I'm just asking. I don't know why. I legit don't know why. Oh, just and then I'm guessing like if left plus right. No, no, what the fuck? I just made a variable total for a reason. If this works, dude, I'm gonna be like ecstatic. Wait, array first.
Oh,
No way this works, right? Fuck it.
run it.
Okay, no, no, there's something. Oh. Start. Start. Wait, is start valid? Yeah, start is valid. It's always 0. Start is fuck. Okay, we got 1 right. And it's 1. That's insane. Output 1? Why is it always 1? I think it returns early. I think this return thing is messing it up because it literally it gets the first valid tree and then it stops. We're so close. It's just not continuing.
Should we return inside the?
What do you
Oh
mean?
no, no. We need it. We need at some points to increment these things.
Hmm. I guess the issue with total is that we need this to be able to return the +1 for the current node.
What's the
What do
error
you?
again? Anyway.
It just
Oh, I get
it's just only going one time. I think it stops early. Like if we did a print statement, I'm pretty sure it would literally just make the first tree and then stop because we had that return. But we need to go again. So I guess the question is, how do we feed it how many nodes are on the left and right tree without returning? Let me think. Two to three. Damn, it's that whole return statement, dude. It's I feel like this is not that we have the right formula, dude. This is literally like all the work. It's just that we're returning. It's not continuing. You know what we could do that would easily fix this? Instead of storing numbers, we'd have to store the actual path. And you know how just we do like subsets and you store it into an array and you return the length of the array for all the valid ones.
that works.
That does work, but it sucks that you have to. I don't know if we have to do that, but that's the only thing I could think of that will definitely because yeah, we have to just append it to a path.
Doesn't it change the whole structure of your code?
Yeah, I feel like there's a way to do this. Like, there's no way you actually have to make the path if they're not asking for the path. Like, like there is a way. The main issue is this. The question is, how do we tell a node how many nodes are on the left and right subtree? Okay. Is it total? Oh lord. Okay. We're not far off. We are not far off. Come on, Prince. Use that PhD brain.
Well, damn.
Come on, man. You genius. You freaking cracked that last problem like insanely fast. Turn total +1. Fuck.
Well, there's two things that's stopping us from like returning. Is this for loop and this return statement, right? This one of these have to have a if condition that says we continue when this.
Oh,
This is always return total plus one.
it always returns
Then we
total
have
plus one.
we have an
Yeah.
early stop case. We need we need we need to either take out the for loop or make this a conditional statement.
So how do we? So how does the return? How would return work if we don't return?
Hmm?
Wait, so how would like? Don't we like? How do you not have a return statement though? Like, how do we tell? Like, let's say we're at the three, and it's left child obviously nothing, right child nothing. How do you tell two that there's only one node on the right hand subtree? Like how? Without returning?
How do you tell it that there's one?
Yeah, because that's what we did here. This is like a way to tell the parent node how many like trees, how many
When we
nodes
have
are
a
on
data
that tree.
have like our well, if we're doing recursion and backtracking, can we not find a way to put this total on top?
I was thinking that too. I was thinking that too. Hmm. So these DFS statements, right and left, should just carry. We have to figure out how to make left and right just carry the amount of nodes on the left and right tree, not like no, right? All right. So if we're at top, all right, let's think about it from the first loop. I guess like when it goes all the way down, right will be 0, and we want left to be 2. How do we get that without having this here? Because this is the issue. Okay. Okay. Hmm. All right. Without the return statement, what does left and right hold now? If we just didn't have that, I feel like right would just
It will
wouldn't they
always
both just return 0?
return
Right?
zero.
Yeah, that's the issue. Hmm. I think I think what if we had the thing remember I was talking about before where I said if the length of the array is 1, return 1. Would that help? Cuz that means when 2 looks to the right, instead of returning 0, right would hold the number 2. Would hold the number 1. Left would hold 0. So now two's left is 0, two's right is 1. How do we return that back up to the 1? Hmm. Yeah, what do we do, dude? What do we do? I'm actually stumped.
So let's start from the top again. All right. So our problem says that we want to try to like create permutations, valid BST permutations.
Yeah.
So we start off with one, right? We can definitely start off with the zeroth index, which is one, and then let's say we had our count equals one, like this equals one for like how many indexes that we have put in. So we do a count plus plus every time here.
Okay.
This starts at zero. So our count is one. Then we go DFS left, which we said that this is equal to blank
0.
blank.
Oh, wait.
So this
Don't
is
we have
going to
zeros
return,
though? You want to
yeah,
return empty array?
return zero, but this is blank. The array is blank
Oh, the
itself,
array is
right?
blank. Yeah, yeah. Thought you meant the return statement was a blank array. Okay, I feel you. I'm following.
So it's zero. Um, our count is, and then our right goes into 2, 3.
Yeah.
Now our count, see, I wanted to make this much simpler instead of this,
Oh Lord. Did I just leave the?
instead of the
Oh, I thought I
count,
left.
count going back to zero, because our count will go back to zero for this iteration. Ooh, but what if, let's say we keep that. Let's say we did that. So our count is zero and then one. Our right has one. Our root has one. And then,
Array has 2 though. Oh, you're talking about starting at 2?
yeah, starting to, currently has one.
Okay, array has
And
1,
then
and our left has 0.
I'm losing where we at. I'm losing where. So 2, 3.
2, 3.
So 2, 3. And then we would iterate through that from start to 3. So our count increases to one. Our DFS right left would take and nothing. And then this would take in a one. I mean, this would take in a three at zero.
Yeah.
This would all till this would become a zero. This would then become a one. This would then, so this was going to return zero again. This is going to return zero. Then we're going to backtrack where this would have uh, tried the three. It returns a one for that three. So then it would do the three, but it will miss the two. No.
Yeah. Wait, I dude, remember that if conditions does that not work if you just say if I? Oh, you can't say if I is not 0 cuz fuck.
Yeah, there's even
Yeah.
another issue if you caught followed what I was saying.
Yeah.
Like it would do the one and then the three, but we don't have the two anymore.
Yeah, I mean, honestly, I mean, either we could like ask ChatGPT to give us a hint, or we could just trash this and just do the way where you like just store the actual subset and return the length of whatever. Because fuck, I don't know anymore.
Yeah, I think mine's that would also yield the issue of, yeah, because if it's permutations, we need something that's keeping track of like what's been used and what's not been used throughout that order. Um,
Left and right
and what is
individual.
that? Is that not a dictionary?
Oh, I don't even know. Maybe. Yeah, I mean,
Too
it sounds
crowded.
like if left and right. Do we need this total? If left and right are independent choices, do we have to really sum them up?
Yeah, I think we've struggled enough on this problem. We need to move forward, do something else, and like, but also figure out like what's wrong. Yeah.
If left and right, okay. What was that thing I had before? Oh no, not that. It was like I think it was return left and right. Do we have to sum up left and right? What can we do with these left and right values? We don't have to. Hmm. Wait a minute,
Yeah.
dude. If left and right both equal 0, doesn't that mean that it like recursed enough to find a valid ordering?
Yeah, but we saw an example where we grabbed the three, but we don't have access to the two, but we didn't use the two.
Oh. Hmm. I don't know if this works. This is merely like a shot in the dark kind of. I can't even explain why I think this. I mean, kind of. Can I just say if right equals 0 and left equals 0, count plug equals 1. So that means that there's no, and then right would eventually equal 0 because that means it got all the way down. Is there a time that it would? I don't know if this works. I'm tripping. There's no way, right? No? Fuck. No, it doesn't work. If we left compare with the right. Oh no, man. All right, well, the timer has 5 minutes and 30 seconds left. I say like if we can't figure it out by then, we gotta look it up. What can we do with the left and right values? Because right now all they return is fucking zeros. Hmm. Before I had left. Every left can pair with a right. Left, right.
Can we not return our total here? What would that do if we returned the total here?
Where?
34, 32.
Oh, wait a minute. What if we did left times right? Wait a minute. 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 If the left. All right. Wait, hold up. So if the left subtree has the number of ways that you can like partition the left nodes, and the right subtree is the number of ways you can partition the right nodes, wouldn't all the combinations be like be like the left times the right.
That makes sense.
So, but the
But then
is
you
an
would
issue though, because
where
left
they
would be
have to go.
0. We have to have this return 1, right? If it's empty, return 1, because anything times 0 is 0, 0, right?
Yeah.
Okay, and we know that there's, by looking at this example 1, that there's 2 valid BSTs that start with 1. So if left is 1, we need right to equal 2. How did we have right equal 2 last time?
Hmm?
We need right to equal 2.
Right
How
will
do we?
equal 1 iteration of 1 to 1, 3, 2.
Yeah. Yeah.
Or 1, 2. But it, yeah.
So
So
how do we get right to equal 2 though? Because I think left equals 0 is good. Okay, let's think about it. So wait, okay. So if there's not, so if we have, if not array, return 1. So from 1, we go to the left and we get 1. We go to the right and we're gonna get 2, 3, right? 2, 3 is the array. It's gonna partition 2, 3. Everything to the left of 3 will be, everything to the left of 2 will be 0. So two's left will be a 1 because it's an empty array. We get 1. Two's right will go down to the 3.
I don't think we need to start because like it's always started at 0 and our for loop starts at 0 and then we'll just move to the next iteration every time. So like
Space
we don't really
case.
need.
Oh, I mean, I don't think it's
Oh,
gonna change anything, but I think we could delete it if the, you could delete if you want, but wait, yeah, I mean, yeah, you could. Yeah, I don't think it matters. I put the base case here. If not length of array, return 1. What happens with the 2 and the 3 in this, with this new change? 2 will return a 1 on the left hand side, and oh, uh,
that's a DP problem for you. I mean, I wanted to
dude,
do.
no, we're so close. We're so, pause. We can, bro. I'm telling, bro, chill, bro. We got this. So what does this tell us? This tells us, so this tells us the number of combinations on the left for the left and right subtree, right? So does that work? Pause. Wait, so what happens on the left tree? We get 2, 3. We go to the left of 2. We get 1. We go to the right of 2. We get a 3. 3 goes to the left, and it gets a 1. A right, it gets a 1. So 1 times 1 is 1. Perfect. 1 times 1 is 1. Then wait a minute.
Mm-hmm.
I think, does this come out of here? wait. So wait. So think about this. When we're at the 3, right? And we get to the left is 1 and the right is 1, right? Right?
What iteration?
Like, so we go 1 and then we go down to the right is 2 and then we go down to the right of 2, which is the 3, right? And now 3, we get to the left is 1 and we go to the right is 1, right? Because there's nothing on the left and right, right?
Mm-hmm.
So that means that there's 1 times 1 or one way to structure the node 3 as a BST. So right here, total equals 1. And then we have count plus equals total. So when it goes back up, so that means we have it's 1. That means now count total should be at 1, right?
Mm-hmm.
And then we go back up to the 2. Now 2, holy shit, do we have to return total? Because what does 2 get from the 3? 2 would get a 2's right is just going to equal 1, right?
Mm-hmm.
2's left is going to equal 1. So that means with the nodes 1, 3, and 2, there's one possible way to make that. I think there's. Hold on, let me try this. Dude, this shit's so confusing. What the hell? What? It says, oh. We have to get rid of the 0 here. Did you mean square root? Where did I put start? Where did I put start? Oh, there. Because this is this. Okay. We're still just getting 1. I think. Why? So the question is, why is count still getting 1? If a count is plus equaling the total, and the total.
Well, this plus equals makes no sense because count will always be 1 at each case. It's not like we're carrying count over every time. So this is always going to be 1 times total, which may also always be 1. The total should at some point be more than 1. Wait, are we even good? No, because we're not returning our, we're not returning the thing we had where our right would increase.
Oh, so left plus right is already the. So left plus right is like the contribution for one root. Because if you get the number of valid orderings for the left and right subtree from a root, then that means that we can just add it to count. So what if we?
I think maybe you meant like the size, because if you want to do the times, didn't you mean the size of what this is instead of just to right? I think that's what you were saying, no?
Yeah, but I guess. Yeah. Hmm. Wait. So if we just do. Wait, does this work? Motherfucker. Oh. Oh, I said equals. It's plus equals. Is this it? I'm fried. I hate this problem. I swear to God. All right, yeah, you know what, man? I get it. You know, I had a good try. I'm axing. I know we're close, but I'm axing AI God. Please give me the hint. Count plus equal left times right. Okay. Your recursion idea is correct. You've already found the core insight. Pick a value as the root and find the number of trees ways to build the left subtree times the ways to build the right subtree. Okay, that was right. You need you don't need the actual array. Right now you're passing around slices like array of yeah. Do you really care about which values in a subtree or just how many? Oh, I think you were saying that. Oh my god. I said if length of array is 0, return 1. He says that's actually correct conceptually. An empty tree counts as one valid structure. Now translate the idea to how many BSTs can I build with 0 nodes? How many BSTs can I build with 0 nodes? Fucking 0. Hint. You want to share my screen? You want to see this?
Yeah, sure.
Uh, damn it. I don't know why I get. I know we could have solved this so easily if I just did the if we just store them like normally. But I think it's a good learning experience though. Whatever. All right. So hint one we got left times right. You don't actually need to store the array. So we could have just passed in values like the length. Base case tweak. That's actually correct conceptually. An empty tree counts as one valid structure. Now translate the idea to how many BSTs can I build with 0 nodes? You can only build one, which is just having nothing. You're recomputing the same things. Your DFS calculates the same sub problems many times. Oh man, as soon as I hear sub problems, I think DP. For example, DFS of 1, 2 will be computed over and over again. This causes exponential time. Think, how can I store values for smaller sizes and reuse them? Keyword memoization or DP? Oh, brother. Rewrite the recurrence in words. Try to express it without code. If I choose a root, the left subtree has k nodes, and the right subtree has n minus 1 minus k nodes. Okay, so minus the root and then minus the k nodes we had on the left subtree. So ways n, where n is the number of ways you can make the subtree, equals the sum over k. What the fuck? If that formula looks familiar. No, it doesn't. Does this look familiar to you?
No.
But me either, dude. That means we really need to know this stuff. If they say it's like, what is ways n equals sum over k? Where k is the nodes of the left subtree? Oh, ways is just the DFS function. So that's just like our left plus our right. So that's like DFS of the number of nodes on the left subtree times the DFS the nodes are right on the left right subtree. Okay, that's cool. If that formula looks familiar, one small bug to notice this line. Tree in range 1 to n plus 1. This creates a list with one element. No way. This creates a list with one element? You're telling me that doesn't do what I thought it does? What does tree do? No way. What the fuck? How do you make it do the thing? I think it's like I, right? Or damn it. I don't even know list comprehension. Perhaps you forgot a comma. Where's the comma?
There's no, there's like, you need I for I in range. You forgot your N.
Oh, for I and okay, that was a pretty big bug. I didn't even. I thought range like printed out the numbers. Okay, 1, 2, 3. That's beautiful. So rewrite the recurrence in words. How to express this without code? If I choose a root, the left subtree has k nodes and the right subtree has n minus 1 minus k nodes. What'd you do with what's temp?
It was counted before or total. You can put it back. I don't know. Honestly.
Oh, I was just wondering. I don't really, I'm not saying it's wrong. Should I just ask for the answer?
Yep.
Just give me the answer. Just give me the. Oh no. Not the DP way. Not the DP way. The way I was trying. Yeah. Okay, we got this. If not array, return 1. Okay, we had that. Count equals my guy. Left equals. Wait, yo, no way. It's just count plus equal left times right. Return count. Oh my fucking god, dude.
That's right.
Wait, is this not what we did? Wait, what? Count plus equal left times right. So this is literally like what we were on. Count plus equals left times right. Is that not? Oh, I think we had this before, but our array was wrong. Yeah, dude, this is the right answer. We had this before, but the list comprehension was wrong. That's why it gave the wrong answer.
Nice.
Oh my god. Oh my god. So let's just quickly go over this again. So I like the whole like the base case because if we have so the real main core of the algorithm is like if you know how many nodes are on the left subtree, you know how many nodes are on the right subtree. Actually, let's just trace it. That's really. So we start off with 1 and we say left of 1 is going to be 1. And now we go right for 1. Right is going to get 2, 3. The left of 2, 3 will be 1. The right will return DFS of 3 because that's the right of 2. Left and right of 3 will be 1, right? So that means for the node 3 all by itself, there is one valid BST to make with that node. So the idea is really like go from the bottom up and see what is the number of valid BSTs to make with just that node. And then once you go up, you just add how many you can make with the other node. What? Okay. So 3, we'll have a left and right of 1. So that means there's one valid way to make the node 3. So count will plus equal left times right, so a 1. We go back up to the 2. Oh wait, and then it returns count down here. So in this case, count will be 1. So that means that 2's right subtree can make one valid BST. two's left subtree can also make one valid BST, but in two different ways. One because there's no nodes, and one because there's one node. Both create one valid BST. So from 2, count will be plus equal 1 times 1, which would be 1. And we add that. So now count should be 2. So that means from 2, there's 2 valid BSTs to make. Yeah. Yeah. Because we could either have 1, 2 or 2, 3, I think. So, right? Are you following me? Are we? Does this make sense?
Yeah, it does.
So when does it loop? Because you know how like 2, 3 has two things. Doesn't have to go and do the next one now.
Yeah, it goes into 3, and then
So
it would try 3, but three's children, but it will return 1. So
wait,
then we have
wait, pause. If we're at 2, I don't think I'm there yet. 3, the left tree returns 1. The right tree is 1, right? From the 2.
well, we have to go into 3.
Oh yeah, so it doesn't actually return anything else. That's where I got. That's where I got caught up. So count is still 1. So now it goes again, and it does say count plus equals 1 times 1. So wait, so is count 2 or no? Is count 2 or 1? I guess that's really what I'm trying to figure out.
When what?
After we finish when we're at the 2.
But we haven't got to 2. We haven't got to the count. Count is 0. No?
Wait, what? Count is 0? No, because once we called DFS on the 3 when it was all by itself, we got to the left and right of 3 and 3 has been like computed already. Because the left of 3 is 0, right?
The left of 3 is 0?
The left of
Oh,
3 has
so,
no, so it'll return a 1.
3 and 2? 1,
Where,
1, 2, and 3? Wait. So maybe you have Excalibur to the right, maybe to help.
yeah, I think so. Damn, holy smokes. Alrighty. We are gonna figure this out today. Alright, so we have the nodes. So we have the
Let me
array
see.
1. I gotta share my whole screen. Okay. So we have 1, 2, 3.
Now I could only see Excalibur, but that's fine.
Oh yeah, because I don't know if it was gonna be too small. If it was like split screen. If you want me to do both, just let me know.
That's fine. I'll look at my own screen.
So we have 1, 2, 3, and count is at 0. We're iterating through the length of the array. So we're starting off, and this represents us picking a root. So we're starting off at left. I'm gonna say L equals DFS of everything to the left of 1. In this case, nothing. So an empty array. And this will equal 1. Now we go to the right. This is where it gets like a little more tricky. DFS. I don't DFS, and it'll be 2, 3, right? And what does this equal? Well, right will go down, and it will make 2 the root. So we go everything to the left of 2. So left of 2, 3 will equal 1, and the right will equal DFS of 3. From there, we go down again, and we see that the left of 3 will equal DFS of an empty array. So just basically 1, right? Right will also equal 1, right? From the 3.
Mm-hmm.
After that, it's been fully resolved. So that means we do count plus equals left times right. So 1 times 1 is 1.
It's one. So then,
So that means we have one valid way to make a tree with one node, is what I'm getting from that.
mm-hmm.
Now, I think it ends. It ends and it returns count on line 30.
Mm-hmm.
But where does that return count to? Oh, DFS of from the 2, right? It returns
Yeah, to two.
yeah, yeah, yeah. So now this finally got resolved, so this equals 1, right?
Yeah.
So DFS of 2, 3, it would
Yes.
have left equals 1, right when we called it on the wait. Oh yeah, on the 3, it equals 1. And then we say count plus equals left times right. So now count has to go up to 2 though, right?
Yeah. Wait, why?
Because
Oh, yes,
2,
yes, yeah.
but what does that mean though? That means that
We found two possible ways to create a tree.
yeah, there's 2 possible ways to create a tree with all right, there's 2 possible ways to create a tree with 2 is the root, uh null is the left. Wait, no. And 3 is the right? Is that what that means?
Yeah, and then we could also do 3, 2, and then
Oh yeah, we also could do 3, yeah, and then 2. I get that. How did that formula just tell us that though?
you mean our drawing?
Yeah, I get the drawing because that means that these the 2 possible ways we could make like the 2 possible valid trees we could make with 2 3 would be 2 3 and 3 2. But how did this like code tell us that? I don't. That's the disconnect for me.
Yeah. So then we were at 2, 3, right? And then we we had one return. We had our right return 1.
The 3. Doesn't the loop go again and we start off at 3 this time? That's the for loop.
Yeah, so in the like we said in the first iteration, we get 1 times 1 is 1, plus equal 1, so count equals 1. You return that to the right where we add the 2. Um, the 2 exhausted all its possibilities. So we're gonna return that right to the 1, and then we're gonna do the 3.
Wait, so count is
So
at 2 then, right? Or is count at 1?
count is at 1. We didn't increase it yet.
Wait, why not?
That's what the algorithm says.
Wait, but when we're iterating to 2 3, the left will be 1 and DFS of right will just be will be the 3, and then we go. I mean, and it calls DFS on 3, and now get returned of 1, and then we have to hit this before we loop to the next one, right?
I understand what you said. So you said 1, 3, and then 2, right?
1, 3, and 2. If we're at, I'm saying we're at 2, 3,
Yeah.
and the left will be a 1, right? Because everything to the left of 2 is 1.
The left would be 1. Yeah. At 2, 3. Yes.
And then the right will be 1 as well, because we call DFS on the 3 alone. And 3's left and right is going to
So
be.
we had to go down a level to get the 1, right?
Yeah,
We had to
yeah,
go
we
down.
went down.
So 3. So 1 times 1 is 1. Count plus equals 1, 0. Because at that point, 0 plus equals 1 is 1. Correct?
But count changed already.
No, if we had the 3, this
Oh,
is
we're
our
at the.
first.
Oh, okay, we're at the
Just
3s. Yeah, so left and right will both be zeros, so that will equal 1. 1 times 1 is 1. So count equals is 1, right?
yeah, and then return that 1 to the.
The 2.
Oh no, I unfortunately accidentally left the chat. Oh, am I back in? Cool.
So we
All right.
return that 1 to the 2.
Yeah. So that 2, that call of 2 is 1, right? So that's right 2. Now
Yeah.
2 doesn't have no more children, so it's gonna recurse back to the left, right?
Wait, what? It
That
doesn't.
call.
You telling me it doesn't hit this line? Why would it not continue?
Oh, it does continue.
So wouldn't
So
that be 2?
1 times 1
Is 1,
is 1.
and count
Our
was
count,
already at 1 from the 3.
but we don't carry count over. The right
Oh,
is equal to 1. The right is equal to 1. Our count is still 0 in this iteration. No?
oh, okay. Damn, that's confusing. Okay, so count is, even though 3 had a count of 1, we just returned that up. Oh, it returned it up to the. We actually counted 3's count inside of 2's right.
Yeah.
Okay. So now count's actually at 1 now, right? Well, it's at 1 in the 2, not the 1.
Yeah.
Okay. So what happens now? Oh, now
So
it
then,
goes again to the 3, right?
so 2 already exhausted its children. So we're gonna go back to the left, where this left,
Wait, left of what?
and left of, well, not left. I mean, the root child, which is 1. So
Wait.
so 1 is gonna try.
Oh.
Yeah.
But this isn't this a wait, what's gonna I thought like we have to loop over 2 3. Is I thought like isn't this like an array of 2 3? So wouldn't it have to go over and I be the 2 this time? I be the 3 because we just went that loop we just did was where I was 0. I has to be 1 now because we have an array of 2 elements before we go back
Yeah.
up. So we're still in the 2's second iteration. Because count is currently 1. So now we have to go again where I is 1.
Yeah.
So we're not at the 1 yet. We're still at the 2. Okay, so we go through and we say left is equal to everything to the left of 3 this time. So that'd be 2. 2 goes down. It sees that it has no left and right. So it returns up a 1. If you go to the right of 3, 3 has nothing to the right of it. So that returns a 1 too. So 1 times 1. So that's where we got 2. So now it's at 2. Holy shit. Oh my god, this is making sense. So with the array 2 3, we could make 2 possible arrangements. which is either 3-2 or 2-3, like what I had here. So now the code and the idea made sense now. So now we recurse back up to the one, and since we've exhausted all the options from one, we just go to the two now and do the same thing.
Yep.
Wow. The hardest part for me was kind of getting that whole like left times right, because I was thinking like left plus right, because like a lot of problems are left plus right, but the times, because if there's one valid way, if there's like, let's say there's three valid ways to make a tree on the left side and three valid ways to make a tree on the right side, we could yeah, I guess that part is kind of confusing. So like you see my screen still, right?
Yeah, but bro, I gotta go in like 1 minute. Um,
Oh, you out? All right, yeah, I'll still be here. I will. I'm gonna figure this out. But this is pretty good. I feel like this would be so
sure.
much easier if I stored the actual nodes like in an array. But it's cool to know how to do it without doing that. So
Oh, you
I
mean
could.
yeah, the permutations way. Yeah, yeah, sure, sure, sure.
Yeah, it would have been like we would have done it in like 5 minutes. But this is cool. Let's learn how to do it this way. So I guess I'll see you tomorrow. Or are you doing something like for New Year's? Wait, no, today is New Year's. I don't know. Just let me know if you're on tomorrow or if you're on
Yeah,
later
all right.
today.
Okay,
All
that's
right,
good.
peace, man. All right, boys. I'm back here again. It's just me. The left times the right. Yo, is that guy at that crack dude here? Champ boy? The left times right thing, I get what you're saying, but like how do you think about that like logically? I don't know if Champ boy's still here. He might have got tired of me like fucking failing this problem. I'm pretty sure like hmm. Well, if there's huh. We know that the left has it could be 3-2, and then it's gonna reverse it, and then it's gonna have a node where two is the root, so it'd be 2-3. Count represents the total number of nodes of trees you could make with the current of nodes. So with just the three, you can make one tree. With the two and the three, you can make one tree. Because if you have two, if there's one x variation to make on the left tree and one x variation to make on the right tree, no matter which way you split, it's gonna be one. Wow. Okay. Wow. If there's 3 ways to make a tree on the left side and 3 ways to make a tree on the right side, then that means there's 9 possible valid trees. Or there's 2 and 2. Let me think about that. So what would be a tree that has 2 valid ways? So like one, maybe not one. One's a little silly. 4, 3, 5, 6. This is 2. So you could either have 3, 2, or you could have 2 and then 3. That's 2 ways. And here you could either have 5, 6, or you could have 6 and then 5. That's 2 ways. So with the root of 2, you could have 4 ways to make a tree. There's no way to just do like why can't we have a counter that counts every node? Because the left and right subtrees are independent choices. Every valid subtree can be paired with every valid right subtree. That pairing creates multiple distinct trees, not just one. Pick 2 as the root, okay. Number of valid right side, number of valid VSTs is 1. Hmm. The left key they have, yeah, the root to be 1 times 2. Wow. That's crazy. Wow. I did not have very much fun. That was terrible. I mean, it wasn't terrible. There's a problem I tried. Non-overlapping intervals. Damn, that multiplication shit's crazy. So in this example here, so what would be the distinct trees to make with 4? Oh, because it'd be 4, then 6, 5. What Leetcode is? Your channel is on my FYP, and I don't know anything about coding. Could you tell me how this works and why you do it? Anyways, trying to learn some new. Oh, it's basically like it's just like problem solving. That's literally it. It's like Leetcode is a website where you can get coding challenges and you have to figure out how to solve them. Think about I don't know. It's like something called competitive programming. There's like big competitions all around. And it's just to show off your coding prowess, I suppose. Yeah, so we have 6, 5. And then we could have obviously like the 3 or 2. We could have 4. 2, 3, 6, 5. We got 4. Which one didn't I do yet? We could have 4, 2, 3, and then 5, 6. And that'd be all the distinct trees. That makes sense. That makes sense. Non-overlapping intervals. Buddy oh buddy. Buddy oh buddy. I kind of get bodied on intervals. Okay, so like a comp, are you in the leaderboard? From the look of your channel, you have been posting for like a year now. Yeah. Nah, man. I'm only ranked like 219,000. Yeah, I did 10 push-ups for the last guy that did it. Sometimes the notification doesn't pop up. I'm not sure why. The last person that subbed was Champ Boy. See, I just did that like as a test. But sometimes, like, did you sub or something? Sometimes it just doesn't like work. If you sub, just let me know. I'll do the push-ups. Wow, that shit hurt my head. I guess we're gonna do non-overlapping intervals next. Shifting letters too? Hell no, I want something easy. Is it Twitch subs or YouTube? Nah, just YouTube. But I don't know how to make it like this is on YouTube, man. So how can I have Twitch subs? Wouldn't that be kind of weird? Dude, holy snap. I need something easy to do. Status is not solved. I thought you were dual streaming. Nah, nah, nah. Only one stream. But yeah, that makes sense. Good point. Premium content is not Premium content. Language is Python 3. All right, what are some questions that we haven't done? This XOR shit. Minimum number of bit flips to convert a number. I know nothing about this like bit manipulation. A bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 1 to 0 or 0 to a 1. Oh, damn. I don't know why it doesn't pop up, but I'll take your word for it. You subbed. For example, if x is 7, the binary representation of 7 is 0, 0 is 1, 1, 1. And we may choose any bit, including any of the leading zeros not shown, and flip it. We can flip. I think that was only like 20 or 30. We can flip the first bit from the right and get 1, 0, 1, 1, 0. Flip the second bit, yeah. And flip the fifth bit from the right, leading 0. Given 2 integers starting goal, the minimum number. How did I know that? This is an easy problem? I don't know shit about bit manipulation. The binary representation of 7. Oh, okay. So I feel like you just get the binary representation of the letter to start. So we get here, and we want to get to. This really works well if they're like the same. This works well if they're the same length. What if one is like really, really long? I'm guessing you would just do like S equals bin of start. And G equals bin of goal. I'm retarded. You gotta print it. Print S and G. And we get the problem is, wouldn't we need to like pad the second one with zeros? I think that would make sense. You have to the whatever one. How do you make them equal length? Since you're doing coding, can I see? I usually use this website where I draw, but yeah, I use Obsidian to like to write like I use Obsidian for everything, like writing notes, everything. Dude, this is crazy. I don't know anything about bit manipulation. I don't even know why I'm trying this. We need to add a zero. We need a way to add a zero to the shorter one. Like the number 7 only has 111. Hmm. I'm gonna say if the length of S is less than, then just add a zero. Damn, flip bits. I feel like having this skill would make it easier. Wait, since you're doing coding, do you having what skill? Like the skill of coding? Yeah, I think it would make these easier, definitely. Or the skill of. So the question is really, how do we change this number here to this number here? Enters 3 because we could change this into a 0, this into a 1, this into a 1. Huh. We need a way to make them equal though. The start has to be like equal to the goal. But like wait. I don't know if I want to look it up though. I feel like that would be like that's like cheating. If this if our start is like bigger than our goal has to have the padding. How do you have huh? How do you get the binary of a number with padding? Yo, you're insane. You're insane. I feel like I'm gonna skip this shit. Because like obviously after you because if we just loop through whichever is the shorter one we have to add zeros to. So in this example here, if our goal is less if our goal is length is which is 3 is less than our start, we need to add the leading 0. While length of goal is less than length of start, g equals 0 plus g. Does that even work? Can you just add a zero? I feel like that does not work. A string and an int. Oh, that's a string. Binary is represented as strings. Okay, that might work now. Okay, that worked. That worked. That worked. I don't know if you're still here, but we're cooking now. And I think we need to do the same thing if it's the other way around. Like if the start is less than the goal. I tried and I did want to learn to make my notes more neat and easy accessible since I wouldn't need the physical book. Oh, I like computers, but it was never really my passion. Cook now. Oh no, oh, yeah, for sure. Well, I think I just go S and G, and then we just do like if S is less than. That's just. I think this is literally it, and we just have to like C count equals 0. And then we just say for I in range. No, for I j in zip S G, count plus equal 1 if I not equal to j. This is it. This is it. Count. This makes so much sense. Submit. Fuck it. Let's get it. Yo, first try? It's really slow. I don't know what these other people did. Oh, wow. Do you do gaming streams? Yeah, sometimes I play Elden Ring. I had an Elden Ring. Wow. Yo, dude. Damn. I'm trying to learn bit manipulation. There's a bunch of bit manipulation safe. Let me show you the how. Wait, let me connect what you wrote to the core bitwise idea. The bit manipulation insight. What you did manually with strings is what XOR does automatically at the bit level. Wow. The XOR automatically. So it tells you if the bits are the same. One, if the bits are different. 0, if the bits are the same. So you can just do this? No way. I don't know what bit manipulation will even help me do. Wait, do you play games as well? So does this actually work? It does. Return bin of start and goal. Oh, one if the bits are different. Wow. Wow. ChatGPT for the win. Yeah, I did not cheat though. I'm just looking. I'm asking ChatGPT for help. Like how much time I should put into bit manipulation. I did solve the question without ChatGPT. So how much bit manipulation should you do? Okay, I'm saying okay. Give me some. I guess I'll do some bit manipulation questions. That's just gonna be what we're gonna do to end off the day, end off the stream. Uh, let's see if we can figure out. Wait, no, hell no. Wait, can't you teach? I think I need to watch a video on that shit because I don't even understand like I don't even understand like all the bitwise things. Bitwise operator. Oh lord, who's like? Yeah,
Hey, what's up,
let's
guys? Welcome to
yeah. If
another
he's
video
Indian, you know
where we
he's
are going
cracked.
to learn about bitwise operators in Python programming. So, guys, the bitwise operators act on operands as if they were strings of binary digits. So, they operate bit by bit, hence, this is the name that is the bitwise operator. So, first of all, let us understand what are the binary numbers. So, over here, for example, as you can see, the number 1 is being represented in the binary form as 0 and 1. Now before this the number 0, it will be represented as 00. That means the binary form can only have two types of digits, that is either 0 or 1. So 0 can be represented as all numbers being 0, then 1 can be represented as the rightmost number can become 1 and the left number is 0 over here. Now for the number 2, what will happen is this number that is 1 over here on the right hand side, it will go on the left hand side. So this 0 has become 1 over here and this 1 will become 0, and that is what we can see over here, that is 1 0. It is the binary form of the number, that is 2, and then the next time this 0 will be converted to 1, so you can see 1 1 as the binary representation of the number 3, and so on the other numbers are also being displayed over here in the form of binary representation. Now guys, as the name
Okay.
suggests, the bitwise operators operate on these kinds of numbers over here. So let's say x it is equal to 10, which is an integer over here, it will be represented as this number in the binary form, and y it is equal to 4, which is represented as this number in the binary form. Over here it is represented as 100, as you can see over here, and on the left hand side we can prefix any number of zeros that we want. So basically, what are the different types of bitwise
What the
operator?
hell?
As you can see, we have AND over here. So bitwise AND, what this will do is, if we do X and Y, basically all these digits, that is first 0 over here, it will be kind of multiplied with the first digit of this number.
In Space Maze, hello. Gonna hit you with a sub because I gotta go, but you have a happy new year and I'll catch you another time. Oh yeah, appreciate you pull up, man. I'm just out here learning about Bitwise. If you sub, let me know because I don't know. The notification doesn't pop up, but I got you with the push-ups. But holy
Over
shit,
here,
this
so it
is
will be 0 in this case. So first 4 digits will be 0 because all the digits in both the numbers are 0. Now over here, this 1, it will be multiplied by 0 over here, and that is why we will get 0 over here in this case. And then this 0 will be multiplied by 1 over here, so again we will get 0. And since the other two numbers are already 0 over here, we will get 0. So this is how the bitwise AND operator will work. It will simply
what?
multiply the binary digits of the number. Now what happens in the bitwise OR? It will be the addition of those binary
Yo, what? This shit's
numbers over
crazy.
here. So as you can see, we have 1010. So 1 plus 0, the result will be 1 over here, and that is what is being displayed as you can see. Now 0 plus 1 will be again 1 over
So
here.
or adds
1 plus
them.
0, again it will be 1 over here, and the next number, that is 0 and 0, it will be 0 over here. Now guys, what if 1 is encountered on the left hand side and on the right hand side as well? So since binary numbers can only be represented by two digits, that is 0 and 1, so 1 plus 1 will be 1 in this case. And guys, similarly we will see what will be the result of the other bitwise operators. So let us move to the VS Code now. Over here, let us say X, it is equal to 10, and let's say Y, it is equal to 4 over here. And
All
now
right,
let
peace,
us
brother.
print all the results of the bitwise operations over here. So we will simply have the print function, and then we will say X and then bitwise AND operator followed by Y over here. Similarly, we will have other operators, that
Wait, so and prints out a multiplies them.
is bitwise OR, and then we have bitwise NOT, bitwise XOR, bitwise right shift, and then we have left shift. So over here, I'll simply copy and paste this line of code over here. Now one by one I will change the operator. Over here it will be bitwise OR, so we use this symbol over here. And for bitwise NOT, we have to use only one variable over here, so we will be using X in this case, and this is the bitwise NOT over here. For bitwise OR, we use the raised to symbol over here, so X raised to Y. And then for right shift and left shift, we have to use the greater than symbol and then some particular number to define how many times we want to shift the digit. So let's say we want to shift 2 times over here, and then the left shift as well, we want to shift 2 times over here. So guys, these are certain bitwise operators as you can see. So let me just save this file and try running this code to see the results of all these bitwise operators.
Okay.
So as you can see, we are getting the results over here. So first of all, it is displaying 0. That's because we have seen the result over here, which was all 0 numbers, and that is why we are getting the numerical number as 0 over here. In the next case, that is bitwise OR, we are getting this number which is represented as 14 in the decimal form. So that is what we are getting, that is 14 over here. Now
How the hell is this
not of
useful?
X. So basically not of X, it is minus 11 over here, and that is what we are getting, that is of X.
You didn't even tell me what that did though. Bitwise not does what? What? What?
Basically not of X, it is minus 11 over here, and that is what we are getting, that is negative 11. And then X XOR Y, so over here the result is 14, and that is what we are getting, that is 14 over
He didn't
here.
even tell me what
Guys,
that
all
did
these
though.
results are in decimal format. If you try converting these decimal format numbers into binary numbers, you will get all these results that are being displayed inside the parenthesis. Over here, the bitwise right shift number, so basically we are reducing.
Yo, this guy's like, no offense, that like, bro, what? That I don't like that guy's like.
Hey friends, welcome back to the channel. So today we're going to be talking about bitwise operators. Now bitwise operators are one of these things that aren't really understood by a great deal of programmers. They're not used a great deal anymore, so you can kind of get away without understanding them, but they're a great thing to have in your tool belt and you never know when you might need to use them. If you end up writing algorithms for encryption or video compression, then it's definitely something you're going to need to know. In my last video, I talked about binary numbers. If you missed it, then make sure you check it out at the end of this video. As you can probably guess from the name, bitwise operators work on individual bits. So if you want to work with binary numbers and perform operations on them, then you need to use bitwise operators. Bitwise operators aren't the most intuitive of things. So before I get started, let's have a look at why we would want to use them.
Okay, I like this video better already.
Used to be used a lot more when computers didn't have as much memory as they do now. If you're working on embedded devices that do have a memory limitation, then they're still very, very useful when you need to know them. The smallest amount of space that a variable can take up is 1 byte. The reason for this is it's the smallest unit of addressable space that a CPU can reference. Even a Boolean variable that can only really have the values true and false should only really take up 1 bit, but in fact it takes up a whole byte with the rest of the 7 bits just padded out. Obviously this isn't a great thing to have if you've got a small device that's got a limited amount of memory. Now you've probably used flags in your application, so just Boolean true-false values. Now most applications, especially those that are referencing physical hardware, will have multiple flags that you want to use. Now if you've got multiple flags in your application and each of them are taking up a byte, then obviously that's going to use a lot more memory than you need to. Now, one of the things that programmers do to save space is to store multiple Boolean flags in 1 byte. As a byte is 8 bits, that means that you can store 8 different Boolean flags in one variable, which is just what you need if you've got a small device and you're trying to save memory. The one place that you might have seen multiple flags being used like this is on Unix file systems. So you might have seen file permissions.
Wait, where did my fucking video go?
644 or 777. The different groups for permissions on a Unix file system. So the first number will be the owner, the second number will be the group they belong to, and the third number will be everyone else. Each number tells you the permissions that that particular group has. So they'll tell you whether you can read the file, write the file, or execute it. To really understand what each of those numbers means, you need to convert the number into binary first. So typical numbers that you might see on a file permission would be like 7, which in binary is 111, which means they can read, they can write, and they can execute. Then there's 6, which in binary is 110, which means that they can read and write to the file,
but not execute
it. And lastly, there's 4, which in binary is 100, which
we
means
can read, not write, and not execute.
They can't write to it and they can't execute it.
Okay, that's
now
cool.
Now that we have an example in mind, let's have a look at the bitwise operators and how they work. There are 6 bitwise operators that you need to know, and we're going to have a look at each of them and work out what they do. Now the first operator that we're going to look at is the AND operator. This is normally denoted with a single ampersand in most programming languages. The best way to describe these operators is by using truth tables. So if we have a look at the numbers 7 and 6, so 7 is 111 and 6 is 110. Using these bitwise operators does a comparison between each of the bits in the number. So for the AND operator, it's going to tell us whether each of those bits match. And if they do, then it will give us a 1. If they don't, it gives us a 0. Here we can see that the first 2 rows have 1 in each column. So the bit matches, in which case the result's going to be 1 for those rows. For the last row, the bits don't match, so that's going to end up with a value of 0. So our final value for doing 7 and 6 is going to be 110, and therefore the result is 6. Going back to our file permission example, the AND operator can actually be used as a test to see if the user has permissions to do something. As the AND operator only gives us back the matching bits, if we compare a user's permissions with our required permissions, then we're going to get back our
This is kind of genius
as the final result if they match. If they don't match, we're going to get back 0. The next operator we're going to look at is the OR operator. The OR operator compares each individual bit and will give you a result if either one or the other is set to 1. If we look at the numbers 5 and 6 in binary in our truth table, we're going to see that for every row that at least one of them is 1. And therefore the final result is going to be 111, which is 7 in decimal. Now in programming, you can use the OR operator to combine multiple permissions. So say you have the read permission and the write permission, and you want the user to have both read and write. You can use the OR operator in this case to combine those permissions and get a final permission set.
It's kind of cool.
If we do that in a code example, this is what it would look like. So we'd have the read and write permissions that we combine with an OR, and then the final permission is therefore going to be 6. You can also use the OR operator when assigning a value as well. Let's say we want to give the user the execute permissions on top of their current read-write permissions. In this case, we can use the OR assignment operator to give them the execute permissions on top of what they already have. So if they have read-write permissions at the moment, they currently have the value is 6, But if we
That's
add
kind of
two
cool.
conditions on top, that's going to give them a final result of 7. The next operator we're going to look at is the exclusive OR operator. Now this requires each of the bits to be the opposite of each other. When one is 0, the other one has to be 1. If we look at the values 5 and 6 again, for the first row, both of the bits match, and therefore the value is going to be 0 with an exclusive OR. But for the second two rows, the columns are either 0 or 1, and therefore the final result is going to be 1 with an exclusive OR. So in binary we have the value 0, 1, 1 as a result, which would be 3 in decimal. If we go back to our permissions example, we can use the exclusive OR to remove a permission from an existing permission set. So let's say the user has read-write permissions, but you want to remove the write permissions from the user. You can do this with an exclusive OR operator on the assignment. So the next operator we're going to
Yo, I kind of that went over my head.
which would be 3 in decimal.
So the user can read, not write, and execute. If you want to take away their permissions, this one you can read, write, and not execute. So everything that matches gets a 0. And if it doesn't match, you get a 1. So now this user can not read, but it can write and execute? Why the fuck?
If we go back to our permissions example, we can use the exclusive OR to remove a permission from an existing permission set. So let's say the user has read-write permissions, but you want to remove the write permissions from the user. You can do this with an exclusive OR operator on the assignment. So the next operator we're going to look at is the NOT operator. The NOT operator is going to give you the opposite value for each of the bits in your number. Unlike the other operators we've been looking at, the NOT operator doesn't work on 2 values, it works on 1 value. The NOT operator will take a number, put it into bits, and then flip the value of each of those bits in the number. If we take the number 5, for example, 5 in binary is 1, 0, 1. So if we use the NOT operator on it, the final result is going to be 0, 1, 0. If you do this example in Python or any other language, you're probably going to get a negative number as the result, which might be a bit surprising at first. As I mentioned in my last video, when you're dealing with signed bytes, the first bit of that number denotes the sign. If it's a 1, then it's going to be a negative number. If it's a 0, it's going to be a positive number. When you're using the NOT operator, it's going to be flipping all those bits. So the first bit's going to become 1, which is therefore going to become a negative. As Python uses an 8-bit number to represent small numbers, 5 is going to look like this in binary.
Python uses an 8-bit number? That's a 1-byte number?
If we use the NOT operator, all of the bits get reversed, and therefore it becomes this. Binary numbers use something called the 2's complement representation. All you really need to understand is if it's a negative number, and therefore it starts with 1, the rest of the number is counting up from minus 128. So if we take this number and start from minus 128, and then add on all of the other bits, we're going to get the final result of minus 6. The last 2 operators we're going to
you killed me with that.
The operators left shift and right shift. As the name suggests, these operators shift the bits of a number either left or right. Again, like the NOT operator, the shift operators only work on a single number, and the second number denotes how many bits you want to shift the number by. So if we take the number 5 in binary, which is this, if we use the left shift operator and shift all the bits by 2, we're going to be moving all of those bits 2 bits to the left, and therefore the final result is going to look like this. When you're shifting numbers to the leftmost bits of the number are just going to get discarded. In our case, they're just 0 anyway, so it doesn't actually make a difference. But if you have a number that has all 1s, then you're going to be losing some of those bits when you move it up. So if we take number 5 and shift it by 2 bits, the final result is going to be 20. If we then take 20, number 5, and shift it...
Yo. Shift it by 2 bits, you're going to get 20? How does this even work? So this is like ones. Putting a 1 here means you have 16. 2, 4, 2, 4, 8, 16? No. Zero, 2, 4, 8, 16. 0, 2, 4. So this is 4 plus 16. Oh, that's how that works. Okay. So this is 32. So if there's a 1 here, if you shifted this 1 over 1 more, it would be 32.
By 2 bits. The final result is going to be 20.
Jesus Christ.
If you then take 20 and then shift it 2 bits to the right, it's no surprise.
Wait. So if you have 20 and you shift it 2 bits to the right, what happens? Let's think about what number this could be. So 0, 2, 4, 8, 16. 0, 2, 4. So it'd be 4. It'd be 5. It'd be 5.
And that's really
Holy shit, dude. All there is to it. This is actually kind of cool.
Bitwise operators. They can seem a bit scary at first, but once you get thinking in
you get a like from me, my friend. That was not even too bad. Bitwise operators. I remember asking ChatGPT to give me some like 191. Minimum number of bit flips. So this question was literally just get the binary of the start and the goal. What is this thing called? The and? Or? Damn. Jesus Christ, I forgot all the bitwise. Oh, this is the XOR. Sets each bit to 1 if the corresponding bits in operands is 1. If both the same, the result is 0. So XOR. Exclusive XOR. So that means that if the damn bitwise operations is crazy. So if the 2 bits are the same, they get a 0. If they're different, they get a 1. Remember you? Yeah. Of course I remember you, man. So the minimum number of bit flips to change a number to another number, you have to just see the difference. So the difference will be every bit that's different, it'll change it into a 1. So you count the number of ones. Okay. Will you like to do trees today? I just did trees. I'm doing bitwise stuff. Is there another bit question? It says 191. Let's do that question. Oh, Jesus Christ. 191. All right, given a positive integer n, write a function that returns the number of set bits in its binary representation. A set bit refers to a bit in binary representation of the number that has a value of 1. Oh, wait. So we just need to return the number of ones that we have inside of this number. Which bitwise operation should we use for that? What does the not do? I think the not does something. What does the not do? Oh, brother. One's component? I feel like I feel like we just. I don't. What is what? Yo, does someone have like. Does anybody have an example? Bitwise operators? Holy shit, you know this is a cracked website. It looks like this. Here's a complement of X. What is X? Oh, here it is. Here it is. Here it is. This is what I need. I should probably copy this somewhere. This is pretty cool. A little table. Flips the bits in the operand similar to negation. All the ones become 0 and all the zeros become 1s. Our questioner wants us to return the numbers of 1s. What? So wouldn't we just do bin? Wouldn't we just do bin in dot count 1? That's literally all we have to do. I think. Yeah, get fucked. Easy. Okay. Let me tell ChatGPT I just solved this shit. What's the next question you want me to do? Power of 2 already did that. 33A counting bits. Number of bits. Oh, he used the and. They used the and in that one. You're doing it in CPP? Yo, I was actually learning. I was learning C++ earlier, or like a couple days ago. I need to get back on that. I'm trying to figure out all these operands. So what does the and do? Similar to the and. Oh fuck, there's an and operator, but but on a bit by bit basis, bits in the result set to 1 if the corresponding operands bits are both 1, otherwise 0. Jesus Christ. I want to learn C++. Nice. Actually, a perfectly acceptable. The true bit trick, you should know this. What are you targeting currently? Targeting bit manipulation. I don't know. So wow n and equals n minus 1. What in the actual fuck does that mean? Why this is powerful? End. Oh, career-wise, a software engineer. In and in removes the lowest bit in the set. Loop only runs for how many times there is a 1. But see, he never even turned it into. He actually never had to turn it into. Wow. I'm trying to understand this. Wow, n and n equals and. So and. What does it say and does again? Similar to the and operator, but bit by bit basis. So it sets it to 1 if the bits are both the same. So if it's the same, it's going to say it's a 1. And if it's different, it's going to say it's a 0. I get that, but what does n minus 1 do? Why are we doing n minus 1? Remove the lowest set bit. Oh. Oh. Because if you do -1 to a number, the bit all the way to the right will be a will become a 0. And then if you do if you do n minus 1, wow, n. So what would that equal? Like, let's say we had the number 5, right? Isn't the number 5 like 1, 0, 1? And if we did and 4, what's 4? 4 would be 0, 0, 1. So 5, what the fuck? So 5 and equals n minus 1. And what and does is if they're a 1, so this would be a 1 in the first position, 0, 0, so it just equals 4. The fuck? And then count goes up by 1? So it's literally just removing 1 bit at a time. Isn't that slow as hell? What? Isn't it slow because we are removing 1 bit at a time? Like what? Like no, it's actually fast. It's faster than checking every bit. All right, yo, you're losing me. This loop does not run once per bit position. It runs once per bit. So the time complexity is O to the number of ones. Oh, so it's actually faster than counting. Wait, so it's just getting in and subtracting 1 each time? That's all it's doing? That's literally all this is doing. Until n equals 0? But let me clarify what subtracting 1 actually does on the bit level. Oh my god, this is crazy. Because that's like the key, because that's the key insight. N minus 1 flips bits. So when you do n and n minus 1, n minus 1 flips all the bits after the rightmost, including the 1. Visual intuition. What the fuck? Hello? Yeah. Reset bits. Wait. So if n is 5, then the binary is 0. Wait, no, it's 1, 0, 1. And 4 would be 0, 1, 0. Like, what does that tell us? Very common point of confusion. Holy shit, I hate this binary stuff is insane. That's what I meant to say, yeah. Why? So, and? Yeah, so it literally just equals 100. Only if they're birth 1. It flips the rightmost bits and all the bits. It flips the rightmost 1 and all the bits to its right. Calling me again. Hello? Yeah. Yeah. Easy.com. Yeah. Um, Okay, so the rightmost bit is the ones. So doing n minus 1 would turn the rightmost bit to a 0. The rightmost bit is a 1. The rightmost 1 is the last one when you're reading from the right. The least significant one, yeah? Okay. It's the 1 in the ones place, yes? Subtract 1. That rightmost bit becomes a 0. Any trailing zeros to the right of it, if they existed, become a 1. So anything to the rightmost 1 is gone. All other bits stay the same. Okay. Each iteration removes 1 count increment each time. Stops when n is 0. Okay. What the fuck is that gonna do for me? Erase the rightmost 1 and then. So erasing the. Where's our problem? Oh yeah, it's this one. So it's just removing. Okay, I kind of get it. So it's just removing one number at a time until n equals 0. Some shit like that, brother. And the and operator keeps the bits the same if they are both 1, otherwise 0. The only way the and will come together. So this is 13. So 1, 2, 4. So that's 5. Wait, 1, 2, 4, 8. So 8 plus 4 is 12 plus 1 is 13. Yeah, it is 13. Minus 1. Minus 1 would be this. Oh, so every time you remove a bit, you remove the rightmost bit, you know you are 1 and do that until 0. Oh, that's kind of cool. So you could, so this iterates through all of the numbers, but if you just did this, you just do while n, and then you did n equals n, well, n equals n minus 1, plus equal. That's actually makes so much sense. Oh shit, that was cool. That was cool. That was cool. I think I'm getting off after this. How long have I been here? 3.5 hours. That's actually pretty cool. Wow. That's actually pretty cool. 136. 136. Does Leetcode 136 don't count? Oh, I must have did it already. Given a non-empty array of integers, return every element that appears twice except for 1. Given a non-empty array of integers, return every element that appears twice except 1. Okay, how would we figure this out with like every element that appears twice except for 1? So one number doesn't appear twice. So can't I just like, which one of these operators do I need? Bits in the result set to 1 if at least one of the corresponding bits in the two operands is 1. Wait. Hold up. Bits in the result set to 1? Holy snap. This, can we make this dark? Bits in the result set to 1 if at least one of the corresponding bits is 1. Wait, not that. Wait, so if we had, so let's say we had 5, 5. So 5 would be 1, 0, 1, then 1, 0, 1. If you did OR on these, what bits in the result set to 1 if at least one of the corresponding bits in the two operands is 1? Oh, so only one of them has to be 1. Wait, what? All right, so if we have 5 and if we compared 5 to 5, this would be 1, 0, 1. So wouldn't they like cancel each other out? You could just like, I feel like they would cancel each other out though. That makes sense to me. Because 2 and 2 would be the same, so it would be 2. Let me think about this. Wait. So if this is 5 and 5, it would result in this. And what happens if we got 4 next? 4 would be what? 0, 1, wait, 0. Wait, hold up. 1, 2, 4. So it would be 0, 0, 1. So 1, 0, 0 before. So 5 and 4. What would happen here if you did the OR operator? 1, 0, 1. Wait, what? So I just get 5 again. So we had 5, 5, and then 4. Wouldn't that just return 5? I feel like we certainly have to sort this. So if we had this array here, what would happen here? Two would be represented as 0, 1, Yeah, 1, 2. And then we did and on the next one, so we get 0, 1. That would just get 2. But then we go to the 1, which would just be 0, 1. And this would return 0. Wait, no, once this return 1, 1. Oh, fucking hell. Bits in the red salt 1 if at least one of the corresponding bits in the two operands is 1. Is this what the number 1 is? 1, 2. Yeah. So this would be 1, 1. Wouldn't that fucking equal 5? Yo. Wait, 1. That would be 3. 1, 1 is 3. How the fuck is that helping me? Yeah, I need the hints. Doing XOR over all the elements leaves just a single number. For the second, I thought 0, 0 would be. Wait, what? You might be right. I just learned about it. Wait, hold up. What? For the second, I thought 0, 0 would be 1, but 0, 0 is. For a second? Wait, you're talking about here? Oh, yeah. Yeah, but 0, 0 is 0. Yeah. Yeah, only turns 1 if you use the AND operand. It's only 1 if one of them is 1. But if we do it like so, essentially the 2 just canceled out itself. And then this is what 1 is. 2 bitwise or 1 would just return 1, 1, which is fucking 3, man. How does that help me? All right, let's look at the hints. Try to solve this without using extra space. Use the XOR trick. Think about how the XOR of all the numbers cancels the pairs. Am I looking at XOR? Oh, that's OR. Wait, where's XOR? Yeah, OR doesn't make sense. Do you see exclusive? Is this XOR? Is that thing XOR? I think this thing is XOR. Bits in the result set to 1 if exactly one of the corresponding bits in the two operands is 1. What the fuck? Result bit set to 0 if both operands. Wait. Bits in the result set to 1 if exactly one operands in the 2 is 1. But the result bit set is 0 if both operands are the same. Okay, so let's look at this XOR thing. Maybe that'll help me. So let's say we look at 2, 2. So this is 2, this is 2. If we exclusive XORed it, if they're the same, it goes 0. And if one of them supposed to be 0, 0. Oh shit. Wow. So if they're the same, it puts a 0. And if they're different, it puts a 1. So if two numbers that are exactly the same will just cancel each other out. And then once we do 1 now, which would just be 0, 1, the same would be 0, and this would just be 1. And you'd be left with, holy shit, okay. So I think I just have to do for n in nums. I think we have to start with something. Num and nums. I'm gonna say n equals. This would just be our result. So res equals nums of 0, and then we just do for I in. Oh, what the fuck am I doing? Chill, brother. Res XOR equals num. Oh snap! I think this should start off at 0. I think this should start off at 0. Res equals 0. That makes sense. What happened if we did start? I don't know. I think I know a way that would definitely work. I'm just gonna do nums of 0, and just do it for I in range length of nums, and then okay, I got you. Let me in like 3 minutes. Let me just finish this problem. Res XOR equals num. Is there a reason it would? Yeah, I was thinking that like because of the first element, like because if I start off at 2 and there was only 1 2, it would cancel out the 2. You know what I'm saying? We want to, if we're gonna start off with the first element, we want to start off here. Oh, here. So it would cancel out this one because this would be the second one, you know? Because what if there was only 1 2? Then it would cancel out, even though it's like incorrect. And then I'll say nums of I. I think you have to do nums of I. Is that how you do that? Is it just x where equals nums of I? I don't think this works. And then just return res. No, man, no. Does this do what I think it's gonna do? Does this, because x or equals? Am I being too advanced right now? This is wrong. I just want to see what it returns. Output 3. Oh shit. I'm still learning DSI. It makes my brain fry. Yo, me too, bro. We got 3. How do we get 3? How do we get 3? What? It just says that XOR. It should be a 0. So if I did 2 and 2, where this is 2 and this is 2, and I did XOR 2 and 2, I don't think this equals it. I don't think I'm supposed to do that. I think nums equals literally nums of I XOR res. That's what I'm going to do. It's XOR with itself at the first element. Oh, so it would equal itself. I think it should be 0, and every time you loop the vector, you need to do XOR the res and store it in res. Yeah. That's exactly the thought I was thinking. Fuck. Wait, no, did I read that wrong? Right? Because let me read that again. I think res should be 0. Oh yeah. Okay. I was thinking that before, but I abandoned that idea. Every time you loop through the vector, you need to XOR the res and store it in res. So when the res is not the same, you store it to check further if the same. Okay. Okay. Does this work? Huh. Wow. I literally thought that. I don't know what I was tripping for. So what are we doing here? Let's trace that. So we start off with 0, and then we do 0 XOR 2. So it'd be 0, 0, and then 2 would be 0, 1. We XOR, so basically it's a 0 if it's the same. So it'd be 0, 1, which would be 2. And then it does that again on another 2. So that'd be 0 here, and then this would result in this. And then next we have a 1. So we have XORing by 0 is like multiplying by 1. XORing by 0 is like... Let me think about that. I don't know. So 0... Wait, what? XORing by 0. XORing by 0. Yeah, it is. Yeah, because like XOR anything by 0, and it would just be the number. And then if we do 2 XOR 1, which would be, this would be the 2, and then 1 would be 0, 1, and we XORed it, this would be... Wait, these are different. Wouldn't this be 1, 1? Am I tripping? The fuck? Because doesn't it return 1 if they're different? It literally says XOR bits in the resulting array result to 1 if one of the corresponding bits of the operands is 1. Result in 0 if both of the corresponding bits are the same. Oh, so if one of them is 1. Yeah. Wouldn't that be 3? Yo, what did I do wrong? Wait, what? Yo, what? What did I... How am I tracing this wrong? Where's that really crack guy that's good at C++? If we start off with... Does this not make sense? Because how the hell did I get 3? So res is 0. So we get 0 XOR 2. So that's like 0, 0 over 2, which would be 0, 2. Oh, no. 0, 1. If they're the same, you get a 0. If one of them is 1, you get a 1. So that means now res is now 2. We go to the next number here, and we say 2 XOR 2. So that would be 2 over 2 If they're the same, you get 0, 0. Okay, that's. So once they become the same, so now this is back to 0. And then we do 1, it turns back to 1. Oh my god. Dude, that's low-key genius. Wow. Mm. Mm-mm-mm. My brain got a rest after that one. Wow. So a number XOR another. So XOR is literally just asking if a number is equal to another number. I think. So what happens if you do XOR on like two numbers that are totally different? Like what if you did 3 XOR 2? So 3 XOR 2 would be like 3 would be no. 3 would be 1. Zero. Wait. 1, 2, 4. It'd be 1, 1 here would be 3. And then over 2 would just be 0, 1, 2, 0. So that's 3 XOR 2. And then what would that equal? If they're different, we would get a 1. If they're the same, we get a 0. So that equals 1. So is XOR like subtraction? Like 3 minus 2? Because this is 1, right? Like, and that's why like 2 XOR 2 equals 0. Because it's subtracting it. What? Yeah, I think that makes sense. Let's solve one more. Holy shit. Now, wait. Now, XOR 2 and 3 by that 0, 0, 1. Wait. XOR 2 and 3 by that 0, 0, 1. So XOR. How do you XOR 3 numbers? Because 0, 0, 1 is 1, and then 2 and 3 is another 2 numbers. What do you mean? Like you mean like XOR 2 and 3 would be 0, 0, 1. If you did XOR both of these. Wait, what would happen here? Hold up. They're all the same, so wouldn't you just get 0, 0, 0? XOR 1, 3 and XOR 1, 2? XOR 1, 3. Okay. Did I do that right? Alright, so XOR 1, 3, and then we need to XOR 1, 2. Shit. Motherfucker. Erase, brother. So 1, 3 would be what? Writing binary. Okay, so we have 0, 1, and then probably another 0, and then 3 would just be 1, 1, 0. And this would be 0, 1, 0, which is 2. Yeah, it's like 1. That's like 3 minus 2. Like I feel like XORing two numbers gets you the absolute difference, because the absolute difference between 2 and 3 is this. And then XOR this one would just be like 0, 0, 1, and then 2 would be, actually you don't need the other trailing 0. Would just be 1, 0, and then they're both different. So you get 1, 1. Whoa. That's 3. What the fuck? Dude, that's crazy. So it's not like subtraction, because that's literally just added them together. Jesus Christ. Jesus Christ. XOR 1, 2 gives you 3? Man, I mean, that's cool. You can XOR two numbers to essentially do a swap without a temp variable. Wait, so is this wrong then? Why is XOR 1, 2? Why did I get 3? Is that wrong? 1. Because I just XOR, because you XOR two numbers, 1 and 2. That gives us 3. That's not swapping. That's kind of crazy. I'm gonna say I solved it, but it's kind of. You are swapping 3 and 2 by the mask. You are swapping 3 and 2. I don't even know what mask means. Swapping 3 and the 2. For swapping 2, no, just do. What? For swapping 2, number, just do. Wait. Let me ask ChatGPT. But I'm kind of confused. So, what did I do? 2, 3? No, 1, 3? 1 XOR 3 would equal 2. Like, uh, A XOR equals B. 1 second. I gotta look at that in a minute. It takes a little bit more brain power. Would equal 3. 3. Kind of weird. Yep. 2 XOR 1 is 3 in binary. It's just bit by bit flipping, which why it duplicates cancel exactly. Why? Oh, why it? I would say cancel duplicates. Duplicate cancel is kind of a weird way to write that. Damn. Okay, give me. I'm gonna do one more. I feel like I solved this one too. I just joined. What question are we doing? I'm just doing bitwise problems. I'm trying to get better at those. Power of 2. I solved this, but like, I don't know if I did the bit trick. Yeah, I did some log. All right, let's see if we can figure out how to do this. Powers, okay. Hint / bit trick. Powers of 2 have exactly 1. Oh my god, that makes sense. I have 1 bit in binary because. Yeah, they have 1 bit in binary. Yeah. So you want to know if n is a power of 2. Wait, can't I just do like. I could literally just do this. Return bin of n dot count 1 equals 1. I'm like so certain that would literally give me the answer. Yeah. But there's some other like I don't like using count because I feel like that's not like what they wanted. So how can we figure that out? Let's look at our bitwise operators. Which one do you think would be the most useful? Similar to the and operator, bits in the resulting set will 1 if the corresponding operand bits are both 1. If they're both 1, think about that. Think about that. If they're both 1, let's draw this out. So let's say that we have the 4. Like, let's say we're given the number 4. We want to say if it's a power of 2. It is. How would you draw 4? It would be 1, 0, 0. Yeah. So how would you know if this is a power of 4? Well, let's look at our bitwise operators. Similar to the and all right, wait. Bits in the results set to 1 if the corresponding operand bits are both 1. Are you up for suggestions or do you want to solve them on your own? I kind of want to figure this one out. Wait, I'll tell you if I need a hint. I think ChatGPT already kind of gave me a hint that like powers of 2 have 1 bit. I'm trying to figure out what bitwise operator to use. So if we know that like this is 4, how can we tell? I just did the counting thing, but there's some bitwise trick. If the bits in the set are equal to are both 1. Okay. So if 4 is this. Try the and operator. Okay. And if they're both 1, it will return 1. How the hell could that help us? Hmm. And what though? There has to be another number. So 100 and let's try 3. What's 3? 3 would be 0. No, tweaking. 1 1 0. So if we line those up, it'd be 0 1 1. And this would be wait, no, this would be 0 0 0. Oh. Wait, so if a number is a power of 2, then it should have no matching bits with 1 minus it. Wait, hold up. So just return n and n minus 1 equals 0? If it equals 0, if it equals 0, that means that there's... Makes sense, I think. Holy shit, no way. Wrong answer? Oh. So they gave us a number 0. Decreasing by a number by 1 will keep all the bits in the same. Yeah, that's what I was thinking. But the thing is with 0. So I'm just say if n equals 0 false, some shit like that. Boom. Okay. I'm kind of getting it. So and returns if both of them returns all the ones that are both ones in the two numbers, or returns one if one of them is a one. XOR returns a one if only one of them is an OR, but it returns a 0 if they're the same. Exclusive OR. This is actually not too bad. Which ones haven't we used yet? Oh, that shifting thing. I don't know if I want any problems with shift right now. That looks complicated. We got 12 minutes to hop off. Let's see if we can get another one in. Where's ChatGPT? Okay. Give me another bitwise. I feel like I'm learning so much. Missing number 268. I feel like I solved this, but like not with any bitwise tricks. I always skip that bitwise stuff, but I feel like it's so powerful. Why is it dark? Get that out of here. Shifting is so fun though, brother. Maybe we have to do it here. I don't know. What they say? 268. I definitely saw this. Ever deal with ever deal with like packing a RPG value into a 6-bit? I've never done that, no. Okay, buddy, let's figure this shit out. Given an array nums containing indistinct numbers in a range from 0 to n, return the only number in the range that is missing from the array. So in this case, it would be 2 because we're missing, it goes 0, 1, then 3. There's some bitwise trick to know this. Why can't I have Dark Reader just on this site, bro? Like, I don't want it everywhere, just on this site. So what? How can we tell if a number is missing? Okay, let's think about this. So we know that it has to include numbers from 0 to n. I think they give us n. Yeah, they give us n. No, they don't. They don't give us n. I guess n would just be a length of array plus 1. As I guess we could deduce that. How do we figure out 2 is missing? Is not a bitwise question? This is not bitwise? It says that. Wait, really? Yeah, it does say. It didn't give me the answer, luckily, but it says hint bit trick. XOR all indices 0 to n and all the numbers in an array. Since every number. Holy shit, this is so smart. Since every number except the missing number appears twice in the XOR, everything else cancels out. Oh my god. Wow. So I'm gonna say this is like sum XOR is going to equal 0 at first. I mean, it can be done easily. Yeah, I know it can. Like, I already solved the question without bitwise. I'm trying to learn bitwise though. Then we just do for I in range length of nums plus 1. because the length of num should be 3, but we need to go to 3, so plus 1, and then we say like sum XOR equals sum XOR XOR I? Is this what they mean? So if I summed up all the XORs, what would that result in? Well, some big ass number. And then if I just do like for num in nums, does this work? No way this works, right? I kind of lost the logic. It kind of made sense. And then just do XOR equals sum XOR num. So this gets all the numbers. No, I don't think I'm supposed to XOR here. I feel like I'm supposed to add. Hold up. Yeah, I don't think this makes sense. Because XORing all the numbers. What? What? Yo. So what the hell is XORing a bunch of numbers do? That is the most genius shit ever. Hold up. So we gotta trace this, boys. I know, like, you get... Yo, I think we're gonna hop on and do some learn CPP later. This is crazy. So if we have, like... We start off with 0. And we XOR 0 and 3, right? Wait, and we're gonna XOR every number from... Wait, does the numbers go from 0? Yeah, 0 to n. So we go 0, 1, 2, 3. Okay. Can you do it in one loop? I could try. But I want to quickly trace this first because I want to figure. I got you with your push-ups. Just give me 1 second. So we have 0 XOR 0 would just be 0 and 0. And then we do 0 XOR 1. So we do this over 1, 0. And what does this equal? They're the same, so this is 0. Yeah, so this would be 1. So this equals 1. And then we do 1 XOR 2. 2 is going to be 1, 0. And what does that equal? 1, 1. 1, 1 is 2. Wait, no. 1, 1 is 3. And then we do 3 XOR 3? Back to 0? Did I do this wrong? There's no way. Because this is back to 0. And then we just do, it went back to 0. And then we do 0. All right, yo, I gotta follow this through. Then we do 3 XOR 3, 0, 0, 0 XOR 0, 0, 0, and 0 XOR 1? Should just be 1, no, 0, 1, and then 0. No. Something's not right here, dude. I traced this not right. This doesn't even make any fucking sense. Was anybody watching this? What did I do wrong? Zero, 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 one. This is 1 though. But we have to return 2. What? I don't know what happened here. It's not wrong. But that means we return 1, but 1's already in here. We're supposed to return 2. And our output even returned 2. How in the tarnation? What? I don't understand. How the hell is this equal 2? All I did was sum up all the XORs from 0 to... What? When you say it's not wrong, how? If the answer is supposed to be 2 and I got 1. What's basically happening is you're XORing all the elements once before the array. Yeah, but where does the 2 come in? But one number is missing, so it doesn't get XORed back in. So 0, so it stays. But one number is missing, so it doesn't get XORed back in. It doesn't get XORed back to 0, so it stays. So what did I do wrong, though? It must be the first loop. Because I'm going to trace this one more time. Hold up. And then I'm having off. It's been like way too many hours. Been here for four fucking hours. Okay. So we start off with 0, right? 0. 0, and we're going to loop through 0 to the length of nums plus 1. So 0, 1, 2, 3. 0 XOR 0 is 0, right? 0 XOR 1, that's 1, right? Yeah, it is, well, let me erase this. 0 XOR 1 is 1 here, and then these are the same, so it's 0. So it's 1. 0 XOR 1 is 1, okay? Now we do 2, so this is 1. 2 would be 1, 0. You're also looping through the list after looping through the range. Yeah, I know. I did that last time and I got 1. I'm trying to figure out why I did something wrong. So 1 XOR 2, because 2 is the next number in the range. We would get 1, 1, right? Because both of these are different, so return a 1 because it's XOR exclusive. Which is that's a goddamn 3. 1 XOR 2 is 3. Yeah. So this equals 3. So now we do 3 XOR 3. which would be 0, 0. And then now we have to loop through this. So we do 3 XOR. Okay, so we do 3 XOR 0. And we get 3. 3 XOR. Wait, no, what? What the fuck? What am I doing? Tripping. We do 3 XOR 3. And then we get 0. Now we do. So we did the 3. Now it's time to do the 0. 0 XOR 0 is just going to be 0. And then 0 XOR 1 would just be 0, 1. These are the same, so we get a 0. This is different. I got 1. Nah, bro. What? Hold up. Print sum XOR. I was supposed to leave a minute ago, but I cannot leave like this. Yes, 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 yes. 0, 1, 3, 0. Okay. I was there perfectly. You XORed 3 twice instead of once. I don't. Did I? Hold on, let me look at this again. And then, so yeah, we did this thing. We got all the way back to 0. And then we started off, we did 3. Wait, whoa. This is where they lost me. What? 3 XOR 3? Because XOR doesn't start at 0. In the second loop. It does, look. Because we loop 3 times. We start at 0, we XOR it by 0, we get 1. By XOR by 2, we get 3. And we XOR by 3, we get 0. It goes back to 0. And then we get, unless you could tell me like why it doesn't. It literally says it right here. Why would it go back to 0 right here and still get the right answer? And then we do 3 XOR 3. That's where I got it wrong. 3 XOR 3 cannot be 0. That's the problem. That's where everything went wrong. What does bit XOR do? Some XOR the loops separately and then XOR them again, you'll get the answer. Oh. Okay. Wait, okay, give me one. Bits in the result set to 1 if at least one of the corresponding bits. No, that's the wrong one. Result bits set to 0 if both of the corresponding bits are the same. Bits in the result set to 1 if exactly one of the corresponding operands is 1. All right. How the hell did they do 3 XOR 3 and get 3? What? What type of fucking sorcery? That should be 0. 3 XOR 3 is 2? No way. 1, 2. It's as if they're the same, you get 0. Yo. This is insane. Can someone explain to me how 3 XOR 3 is goddamn 2? What's 3 XOR 3? It's 0. How the fuck does this... It's printing the XOR after the operation. So it's 3 XOR 0, then it did 3 XOR 1. No, I'm talking about down here, though, after the first one. Because this loop starts off at 3. And when the first loop ended, XOR was already 3. So it's doing 3 XOR 3, no? Because according to array XOR, it is done by 3, then 0, then 1. That's how array XOR? Yeah, oh yeah, that's what I was saying. That makes sense. I'm gonna have to just ask ChatGPT. I really want to leave after this. Walk me through this code, please. Okay, XOR is 1. Okay. It equals 3. Okay, so we literally got to here. After this loop, so XOR is 0, 0. Yeah. I was here. Oh, 0 XOR 3 XOR 0. Oh, so so number's 3. So 0 XOR 3 is 3. So 3 XOR 0 is 3. And 3 XOR 1 is 2. What did I write? Why did I do 3 and 3? Oh, my bad. Yo, I think you told me that. I think I'm just tired. I literally said it's literally 0, 0 XOR 3, which is here. Both of these are different, so it's just 3. 3 XOR 0 is 0, 0. What? Yeah. And then we do 1. Yep, you're right. It's that's literally how that works. Yep, that works. Dude, that's kind of freaky, dude. Like, how are you supposed to understand this? XORing all the numbers in nums starts off at 0 from the range will give you 0, and then you XOR all these and it'll give you 2. Right, how it works conceptually. XORing all numbers from 0 to n expected numbers. Okay. XOR all the numbers and actual numbers. Because XOR cancels out duplicates, everything that exists in nums cancels out the counterpart in the range. Try a mean little question. These are two because you're cracked, bro. You're too good at this shit. Nah, man. I think I'm hopping off. Oh wait. I mean, yeah. I might hop on later, man. It's already like it's late, and I've been here for 4.5 hours. I appreciate y'all pulling up. Oh, I gotta do some dudes push-ups. Give me a second. Yeah, I think I'm gonna eat lunch. 4 hours for me is like do a linked list or something. You know what, May? We're gonna reverse a linked list just for you before we leave. We're gonna leave. We're gonna leave on a dub, man. Yo, XOR shit is insane. That's kind of smart though. That O of 1 trick is like low key genius. All right, buddy. I didn't even know there was a reverse linked list too. Oh yeah, let's do this. Let's do this, baby. Why don't you try Code Forces? I tried to make an account and they wouldn't send me the verification email. Like I legit tried to make an account on everything. I even looked it up and they were like, "Oh no." And I gotta learn C++. Give me like, I don't know. Let's go, baby. Let's go, baby. Oh yeah, we just beat that shit. Anyway, yeah, I tried Code Forces, man. Whoa, it's look register. Wait, no, I literally look at this. Only use a subset of CPP. I can't send syntax. They will not even let me like make an account, dude. Hold up, let me try something. It says no handle with that email. Man, I hate Code Forces. They will not let me make an account. Use Gmail. All right, one second. Let me make an account. I guess that's what I'm doing. Handle's already in use. They stole my handle, bro. What the hell? Yo, that's crazy. They let me make an account. You actually have to use Gmail. What the hell? I think I actually have a Code Forces account now. Wait, let me wait, so can I enter now? What? Invalid handle or password. I just fucking Are you tripping? Oh yeah, I got you. I'll add you before I leave. I can't figure out what I'm so confused. Wait, they won't let me log in though. It literally just says that like my password's incorrect. Okay, whatever. I guess I gotta change my password, even though I literally just made it. Kind of silly, bro. Can't hold you. Wait, it says registered 2 minutes ago. Give me a second. Add me. My name is Soup ZZ. Two Z's, two Z's. Yeah, that's what I'm trying to do right now. Password mismatch. I can't type for shit then. Okay, we're in. We're in. We're in. Boom. We got an account. Phew. Uh, wait. So how do I make a? I need to make. I need to get a profile picture that's kind of cool. Yo, add me. We could. Okay, there we go. I have an account now. Nice. This dude Kevin's cracked, bro. What? How do I add you? Is there like a friend section? Hold up. Hold up. Hold up. How the hell do you look at? Oh, you have a new message. Oh, hello. Oh shit, you're 1700. How do I accept you? Where are we friends now? I have no clue. You have a cool profile picture. I'm just assume that like we're added. I need a better profile picture. I picked like some random image on my computer. I'm not too pleased with it. Click the star. Okay, got you. I'll use my same picture from Leetcode. Besides my handle. Okay, I got you. Oh, I got you. I added you. Damn. How do I? So how do I solve a question? Groups? Is it called groups? I don't know. Home? Why is this site so like it looks so shit? Top catalog contest? Let's go contest. I have no clue. I don't know. I'm gonna figure this out another time. I've been on here for like 5 hours. Anyway, bro, go to the placements tabs and select one. Oh, problem set. Problem set. Production of 2 snowmen. How do you know the difficulty? I'm guessing greedy sorting math 2 pointers. Ugh, it's white. I guess that's fine. 8. Oh, this is the rating. 800. That sounds my speed. How do you submit something? Oh. Oh. Lord. Do they even have Python here? Oh, they do. Wait, so if you want to submit something, you have to make a file? So I have to use code blocks? I don't know. I feel like I need to learn more C++. Anyway, I'm about to hop off though. I'm tired. I'm gonna go eat lunch. Appreciate you pulling up, man. I'll be on another day. Maybe I'll be on next time. I gotta do more learn C++. I found this cool website. Hey, where the fuck it at? LearnCPP.com. And I've been going through this, so I think I'm gonna go through all the C++ stuff. Not right now, but another time. You can submit on the submit tab above. Oh yeah, I see it. To submit. Damn, this already looks harder than Leetcode. I don't know why. It doesn't look as beautiful.